Hello friends, welcome to Wiki Lectures. In this lecture, we are discussing the Karnataka State 2020 Physics question paper.
Now, this is our first question. Now, the question is to identify the vector that is perpendicular to both I plus 2j minus 3k and minus I plus 2j, minus I plus j minus 2k. Now, let us consider this vector as A and this as B. Okay. Now, we have to identify a vector C such that A dot C and B dot C both are equal to 0. Now that means our aim is to find out the vector C. Now here we have the four options given. Okay, now let us do one by one. Here we can write I times I, that is 1, plus here you have 2j, 3j, that is 6, minus 3 times 2, that is minus 6. That means which is not equal to 0, right? Now here again we have I times 2i. You can put I times 2i, which is nothing but 2, plus 2 times 3, that is 6, minus 3 times 1 is minus 3, again which is not equal to 0. Now you have the third option, I times I, that is minus 1, 2j times 5j, that is 10, again minus 3 times plus 3, that is minus 9. So minus that is equal to 0. Now you have the fourth option, I times I, that is equal to 1, 2j times j, that is plus 2, minus 3 times 1, that is minus 3. So here is also 0. So your required answer should be either this one, this vector, that is minus I plus 5j plus 3k, or I plus j plus k. Now here again we have the vector B. Now what we have to do is use this vector B, that is vector B minus I plus j minus 2k. Now take the vector C that we have got from the option C, that is minus what was the vector, minus I plus 5j plus 3k. Okay, now just put the dot product. What you will get is minus I times I, that is 1, plus j times 5, that is 5, 2 times minus 3, that is minus 6. So this is 5 plus that's equal to 0. So the required answer is minus I plus 5j plus 3k. And just for confirmation, let us check with the last option, that is I plus j plus k. Now what we will do is we will use our vector C, that is I plus j plus k dot product with the vector B. What is vector B? Here minus I plus j minus 2k. So what is the dot product giving you? I times, that is minus 1 plus 1, and here you have minus 2, which is not equal to 0. So your option is option C, and the value of C is equal to vector C is equal to minus I plus 5j plus 3k. So this is the required answer. Here the same question we can discuss in another way, that the previous method that we used was trial and error method. Now here we have a direct method called, there is a direct method where we can simply write the vector C is equal to xi plus yj plus zk. This is any arbitrary vector. Then we have two vectors. One is a is equal to I plus 2j minus 3k, right? So here we can write a dot c should be equal to a is 1, so r1, that is x, plus here you have 2j, here y, that is x plus 2y, and minus 3 times z, that is 3z. Now that is from a dot c. Now we can write b dot c, which is b is this vector, right? So now b dot c is given by, now what is a dot c? A dot c should be equal to 0 because they both are perpendicular. Now b dot c you can write it as minus I times x, that is minus x, and j times y, that is y, that is plus y, and minus 2 times z, that is minus 2z. So that should be equal to 0. Now you have two equations. This is equation 1 and this is equation 2, and these two equations you can just add 1 and 2. What you are getting? You are getting 3y minus 5z equal to 0. Now take each option and check the coefficient of y and z and put it equal to this. For example, now we will check with the option A. What is option A? A is I plus 3j plus 2k, right? Here this is the 3 times y. What is y? Y is 3. 3 times y is nothing but 9, minus 5 times z is nothing but 2. 5 times z is 2. So 9 minus 10 is not equal to 0. Now we have already found out. Now check this option C. What you will get is 3 times, what is y? 5, right? 3 times 5 minus 5 times z. What is z here? 3, equal to what? 3 5 15 minus 15, which is equal to 0. And you can also check here 2 times, here you have 3y minus 5z. Here 3y minus y 3, right? Yeah. So 3 times y is nothing but 3 into 3 minus 5 into 1, which is not equal to 0. Now the last option 3 into j, that is y is 1 minus 5 into 1, which is also not equal to 0. So only option that you are getting is here, right? So option C. Okay, the second question: if vector A is equal to 2yi minus x square yj and phi, this is scalar, 2x square y. Then what is a bar dot del phi at 1 comma 1. Now just let us find out what is del phi. Okay. Del phi is equal to I cap into dou by dou x of phi plus j cap into dou by dou y of phi plus k cap times dou by dou z of phi. Now that can be written as I times dou by dou x of phi. This is our phi, 2x square y. There is nothing but 4xy plus j times dou by dou y of phi, that is 2x square. Now what is del phi at 1 comma 1? Just put the value of x and y equal to 1 and 1. So what you will get is 4i cap plus 2j cap. Right. Now what you want? Now we want is vector A at 1 comma 1, which is nothing but 2yi minus x square y j. Right. Now at 1 comma 1 what happens? Y equal to 1, so 2i cap minus 1 j cap, both are 1, so j cap. Now you want the dot product of what and what? You want a bar dot del phi, so that's equal to, take the both vectors, 2i cap minus j cap dot 4i plus 2j, so that is 8 minus 2, which is nothing but 6. Now your option is C. Coming to the third question, the value of the integral from minus infinity to plus infinity d by dx of delta of x into e to the power ikx dx. Now this is nothing but the Dirac delta function and k is constant. Now the question is the integral of this function. Now before going into the question, let us define few properties of Dirac delta function, that is integral from minus infinity to plus infinity delta of x dx is equal to 1. Now this is nothing but step function. Okay. Now here we can also write the d by dx of this particular step function will be equal to delta of x, right, which is nothing but Dirac delta function. Now few more properties are integral a to b f of x into delta of x minus c is equal to, now there are two values for this. If this c lies between a and b, then the value is f of c. That means a less than or equal to c less than or equal to b. Okay, and the value will be equal to 0 otherwise. Okay, otherwise this value will be equal to 0. Now this is the point number 1. Here you have point number 2. The third point is delta of minus x is equal to delta of x. Now what is this meaning? It means that this Dirac delta function, delta of x, is an even function, right? Now the fourth point is delta of a times x is equal to 1 by mod a into delta of x. Fifth point is delta of x square minus a square is equal to 1 by 2 times mod a into delta of, here you have, into delta of x plus a plus delta of x minus a. Okay. Yeah. Now the sixth point is integral f of x into delta n of x dx. Now what is this? Delta n of x is nothing but nth derivative of the function delta, okay, is equal to minus 1 times integral first derivative of the function f into delta of n minus 1 times x, which means n minus 1th derivative of the delta, okay, into dx. Okay, now coming to our question. The question is integral minus infinity to plus infinity d by dx of delta of x into e to the power I kx dx. Now this is the function. Here this is the first derivative of delta of x. Now you can write the sixth point what we have discussed here as integral minus infinity to plus infinity e to the power I kx, that is the function that we have, into delta dash of x, right, dx. So that is equal to minus 1 times integral first derivative of the function, that is e to the power I kx into ik, because the derivative of ikx, times the n minus 1th derivative, which means here n is equal to 1, n minus 1 means 1 minus 1 0, so delta of x. Now bring this ik outside. So what we have, it is minus 1 times ik integral delta of x into e to the power ikx dx. Now this is x. Now go back to our second this thing, that is second point. Here we have written second point, that is integral a to b f of x into delta of x minus c equal to f of c. Now this is from minus infinity to plus infinity, and what is here? Delta of x. So delta of x we can write it as delta of x minus 0 into e to the power ikx, right? So put x equal to 0 here, you get what is f of c, function of c. So e to the power x equal to 0, so that is nothing but 1. So minus 1 into ik into 1, that is nothing but minus ik. Question number 4. Two independent solutions of the following differential equation. So this is the differential equation given. So this we can write it as d square plus 3d plus 2 equal to 0 times y. And then what is d? D is nothing but d by dx. And what is d square? D is d square divided by dx square, second derivative. Now this is equation in two variable. We can split the middle term and write d plus 1 into d plus 2 times y equal to 0, right? So what is the value of d? D equal to minus 1 and d equal to minus 2. So then what is y? Solution is nothing but e power m1x and e power m2x. What are m1 and m2? M1 and m2 are the solutions. So you can write m1 is minus 1, so e power minus x and e power minus 2x. So option A. The number of independent components of real antisymmetric tensor of rank 2 in 4 dimensions. So you know this is a 4 by 4 matrix. Okay, so it is an antisymmetric tensor. Antisymmetric means your diagonal elements, all diagonal elements will be equal to 0. So all diagonal elements are 0. So what is the question? The question is about independent component or independent elements. You can write independent elements in this 4 by 4 matrix. For antisymmetric, number of independent element is nothing but n into n minus 1 divided by 2, where n is the order of the matrix, where n is nothing but order of the matrix. So what is the order here? 4. 4 into 3 divided by 2, that is 2 into 3 is 36. So now suppose this was a, instead of antisymmetric, symmetric matrix. If it was symmetric matrix, then n into n plus 1 divided by 2. And what do you mean by antisymmetric? Antisymmetric means A transpose must be equal to minus A. A transpose equal to minus A. Symmetric means A transpose should be equal to A. So for symmetric matrix, it is n into n plus 1 by 2. For example, if it was this question in terms of symmetric, so 4 into 5 by 2. So then that is nothing but 10. Okay. Now, how many elements are there? 16 elements are there in a 4 by 4 matrix. Out of the 16 elements, 10 are independent. So here the next question, V is given is 2xy plus 3 for a analytical function. So analytical function, and f of z is the analytic function. So u of x comma y plus I of v of x comma y. Okay, so where u is the real part and v is the imaginary part. So in this question, in this analytical function, v is given, that is imaginary part is given, and condition is also given, boundary condition f of z equal to 0. Then at f of z equal to 0, it is nothing but 2 plus 3i. So what do you mean by f of z? Z is nothing but x plus iy. Okay, so at z equal to 0 means it is nothing but x plus iy equal to 0. If x plus iy has to be 0, then x is equal to 0 and y equal to 0. Separately they must be equal to 0. Only then z will be equal to 0. So the condition given is f of z at x equal to 0 and y equal to 0 is nothing but 2 plus 3i. That means your u is equal to 2 and your v value at z equal to 0 is 3. Now coming to the question, we have v given. How to find out u is the question. So u is nothing but integral dou v by dou y into dx minus integral dou v by dou x into dy. Dou v by dou y. Now what is dou v by dou y? With respect to y you have to differentiate. So you get 2x. So integral 2x dx minus integral dou v by dou x is nothing but 2y. 2y dy. Plus some constant will be there. Constant of integration. So that is equal to 2x integral x square minus y square 2y integral plus c. So that is u. But u at x equal to 0, y equal to 0 is given as 2. Okay. So u at x equal to 0 and y equal to 0. So that is equal to 0 minus 0 plus c equal to what? 2. So which means c equal to 2. Just substitute the value of c here, you get the answer. So x square minus y square plus 2. So this is your option C. So the value of the integral, closed integral over C, where C is a unit circle with origin as its center, and integration is done in clockwise path. So these are the things you have to remember. This is clockwise. So integral. Now what is z? Z is a complex number, x plus iy. So in polar coordinate we can write z is equal to r e power I theta. Okay, now it is a unit circle. Unit circle means the radius will be equal to 1. So z is nothing but e power I theta. So we got the value of z. Now we want dz. What is dz? E power I theta into its derivative, right? Whatever is on the exponential term. So I d theta. So dz is okay. Now just substitute these values here in our integral. So integral dz is nothing but e power I theta I d theta divided by e power I theta. From where to where? Now this is clockwise. Clockwise means in this way. That means you have 0 here, you have 2 pi here. If it was anti-clockwise, you go from this side, right? From 0 to 2 pi. Since it is clockwise, it goes in this direction. That means from 2 pi you have to go to 0. So what is left? I d theta get cancelled. So integral is from 2 pi to 0. Okay. So I d theta, I comes outside, d theta, theta. From where to where? 2 pi to 0. So that is nothing but I into 0 minus 2 pi. So 0 minus 2 pi. So minus 2 pi I. So your answer is B. Here we can see the question number 8. the number of independent parameters of the group O3 and SU of 2, okay, are respectively. Now what independent parameters is what is asked. Now here you have O3, right? This is O3 is R of, that means this is a rotational matrix. Now what is O3? O3 is nothing but orthogonal group. Orthogonal group, okay, it's an orthogonal group in three-dimensional Euclidean geometry. Now when you write O3, it's a rotational matrix. It's a function of psi, theta and phi. Now psi is nothing but the radius. Now here from this, for all the points on this sphere represents what? An orthogonal group, okay, or the element in this group. Then what are the variables? This is variables are psi, theta and phi. So how many? 3 independent parameters. Now what is SU of 2? Now this is special unitary group of 2 by 2 matrix, okay. Now so this can be written as A. This is one of the example, cos theta by 2 e to the power I psi plus phi. Now here also you can see there are 3 independent variables. One is theta, psi and phi. So here also we get 3 independent parameters. Now here they have the limits for each of the variable, okay. So what is the answer here? 3, 3. So your option is option A. Any Hermitian 2 by 2 matrix H can be expressed in terms of 2 by 2 identity matrix I and 3 Pauli sigma matrices sigma x, sigma y and sigma z as H is equal to A naught times I, where I is an identity matrix, and plus sum over Aj into sigma j, where j equal to x, y and z. So this we can write it as H is equal to A naught into I plus sigma x into Ax plus sigma y into Ay plus sigma z into Az. Now this is one of the property of spin matrix. Pauli's spin matrices. Now what are A naught, Ax, Ay and Az? A naught, Ax, Ay and Az are real numbers. Not only Hermitian, any 2 by 2 matrix can be represented in this form. Now what about spin 1? This is spin half, Pauli spin half matrices. What about spin 1? Then also every 3 by 3 matrix, 3 by 3 matrix H, Hermitian matrix or any matrix of square matrix of order 3 can be expressed as in this form. Then this becomes identity matrix of 3, order 3, and sigma x, sigma matrices are spin 1 matrices. So your option is where A naught, Ax, Ay, Az are real numbers. One of the eigenvalues of this matrix e to the power A is given as e to the power alpha, where A is this given 3 by 3 matrix. Since it is 3 by 3 matrix, there are 3 eigenvalues, okay, that we'll find out. So one of the is given as e to the power alpha. The question is the product of the other 2 eigenvalues. Now let us take this matrix A. So what is the determinant of this A? Determinant of A is equal to alpha into 0, minus I into minus I, that is 1, so alpha square. So 0 minus alpha square, that is nothing but minus alpha cube. So what is sum of the diagonal elements? Sum of the diagonal element is nothing but sum of the eigenvalues. Sum of diagonal element is equal to sum of eigenvalue. So what is the diagonal elements? Alpha, 0 and 0. So sum is equal to alpha. So product is equal to minus alpha cube, sum is equal to alpha. So this we can write it as alpha, alpha and minus alpha. You see, alpha, alpha and minus alpha. Product is equal to alpha cube and sum is equal to alpha. So minus alpha, alpha cube. So our eigenvalues are correct. Now what is the question? E to the power alpha. So e to the power alpha or e to the power a. What are the eigenvalues of e to the power a? It's nothing but e to the power alpha, e to the power alpha and e to the power minus alpha. Now, one is given. One of the eigenvalues is given as e to the power alpha. You are asked to find out the product of these two eigenvalues. So e to the power alpha into e to the power minus alpha, that is nothing but e to the power 0, that is equal to 1. Now if eigenvalues are given, eigenvalues of a matrix A is given as lambda 1, lambda 2 and lambda 3, then eigenvalues of e to the power A is nothing but e to the power lambda 1, e to the power lambda 2 and e to the power lambda 3. A simple question from probability. The 3 fair coins are tossed. Find the probability of getting 1 head and 2 tails. So write it in this form. So combination of 3 head over. So again combination of 2 heads. HHT, HTH, THH. So combination of 2 head is also over. Now combination of 1 head, HTT, THT, okay, then TTH over the combination of 0 head or 3T. So 1, 2, 3, 4, 5, 6, 7, 8. So 2 to the power 3, 8 combinations. Now we have to get 1 head and 2 tails. Wherever there is 1 head, you can take it. 1 head and 2 tails. From where you start writing the 2 tails? Here, 1 head, 2 tail. So here 2 tail, 2 tails. So 3 out of 8. So option C. Now here you have a matrix given A equal to 1 by 3 into all 1, 1, 1. Now some properties. There is a property of the matrix. If all entries are same, then lambda equal to trace of this matrix and all other lambdas are 0, 0 etc. up to n minus 1, where n is the order. So it will have n eigenvalues. Out of that n eigenvalue, one eigenvalue will be non-zero, that is trace. So here what is the trace? That is equal to 3. So trace equal to 3. Okay, so what are the eigenvalues? Lambda 1 equal to 3, lambda 2 equal to 0, lambda 3 equal to 0. Now but look at the matrix A. You have to divide it by 1 by 3. Now when you divide a matrix by 1 by 3, its eigenvalue will get reduced by 3. So lambda 1 is equal to 3 by 3, that is 1. Lambda 2 is 0 again. Lambda 3 equal to 0. Okay. Now, what is the question? Find the value of determinant of e to the power a. Determinant means, determinant is nothing but product of eigenvalues. Product of eigenvalues. Now, if lambda 1, lambda 2, lambda 3 are the eigenvalues of this matrix A, what are the eigenvalues of e to the power a? That is nothing but e to the power 1, e to the power 0 and e to the power 0. These are the eigenvalues of e to the power a. So what is the determinant? Determinant is product. E to the power 0 is 1, e to the power 0 is 1, e to the power 1 is e. So determinant equal to e. So your option B. Now here most of them will have a confusion. We are taking 1 by 3 from any one of the rows or columns. Is it applicable, or is this 1 by 3 only for this row? Any one of the row? No, this is for all matrix. Now when you are dealing with operations on matrix, operation means matrix operations like changing row, taking 1 by 3 out of a row, then it is given only from one row you will take out the common, but this 1 by 3 is common to all the matrices. Similarly, if you take the determinant of this matrix 1 1 1 1 1 1 1 1, then this determinant is nothing but 0, right? So this is also product of lambda 1, lambda 2 and lambda 3. Lambda 1 into lambda 2 is nothing but 0. Okay, then if you divide by 1 by 3, then the determinant, this lambda also will reduce by 1 by 3. So lambda by 3 into lambda 1 by 3 into lambda 2 by 3 into lambda 3 by 3. So this is the determinant. If this one of them was not 0, you would get a value in this way. Okay. A particle thrown upward from Earth's surface reaches a height of 100 meters and returns back. The acceleration of the particle at its highest point of reach has a value. Now, this is the scenario. We have a particle, and this particle is moving at a above height and then coming down. Now the question is, at this point, what is the acceleration? This is 100 meter above. Okay. Now, at this point we know velocity equal to 0, because it reaches maximum height, its velocity will be equal to 0, and then it descends down. Then what about acceleration? The acceleration will remain same. It is 9.8 meter per second square. It will be g. Now suppose if you have any doubt, just look into this scenario. Suppose acceleration is equal to 0. Okay, if acceleration equal to 0, then let us take the force. Force is equal to mass into acceleration, that is equal to 0. That means force on this particle when it reaches this particular position is 0. If the force on this particle is 0, that means the particle is stationary, that is in equilibrium. Stationary. There is no external force, means it is stationary. If it is stationary, means it is standing in the mid-air. It doesn't happen, it is falling down. Now assume it is not equal to gravity, not equal to or acceleration not equal to gravity. In that case, what happens is it will the time of flight, time taken to reach from this point to this point, for example if it is t, time taken by particle to reach from this point, let me tell A to B, if time taken is from A to B is equal to t, then time from B to A will be equal to t dash if there is a change in acceleration. But we know time of flight is same. Time of flight means it's not a complete, like A to B will be equal to this, t dash must be equal to t. That is one part of the question. I mean, this is what it is. Now another idea, if on the surface at any point if you go above, if you reach height above the ground, there is a difference in acceleration. The acceleration at this point is not equal to acceleration at this point. There is a change, but that change is very negligible. Depends on the height each. Now as you go down the earth, then also there is change in acceleration. What is that change? If you go up, the acceleration g dash is equal to g into 1 minus 2h divided by re, where re is the radius of earth, around 6.4 into 10 to the power 6 meter. Okay, now as you go down the earth, then also there is change in acceleration, that is given by 1 minus 2 not 2, there is h divided by re, there is no 2. So when you go down the earth also changes, when you go up the earth also changes. There is gravity. Even on International Space Station there is gravity. Even though we see people floating, it is still there is gravity due to earth. So this is what it is. Now in this question, if you put this height h equal to 100 meter, this is just 10 to the power 2, comparable to 10 to the this re, this value is very small, so our g dash will be almost equal to g. That is why in this question, but this question is an entirely different, this is not asking about what is the change, what will be the gravity at that point. Okay, so option is D. Suppose the radius of the earth were shrink by 1%, its mass in the mass is remaining same, and acceleration due to gravity would be. Now what is the formula? G is equal to capital G by into m divided by r square. Now if there is a change in delta G, the G is constant, and change in delta m into r square, that means 2 times change in r, which means what? If there is 1% change in mass, there would be a equivalent 1% change in gravity, and if there is 1% change in radius, there will be an equivalent 2% change in gravity. Here radius should be same, here mass. Suppose in both, for mass there is 1% change, as well as for this radius there is 1%, their equivalent change will be 3%. Now if this formulas or this idea doesn't stick to your mind, you can go for usual method, that is assume our values are some constants, gm by r square. Now for this time being we will take capital G, m and r are 1. Okay, So if G, M and R equal to 1, then our gravity is nothing but 1. Acceleration due to gravity is equal to 1. Okay, now if there is a 1% change in 1% change in R, so our G is equal to this 1 and 1 would remain same. Instead of R square we have 0.99. Instead of 1 we have 0.99. There is 1% change. So this is nothing but 1 divided by 0.9801. 99 square is 9801. This value is nearly equal to 1.0203. Okay. Now earlier you had 1, now you have 1.0203. What is the change? 0.0203. This is the change with respect to 1. So what is the percentage change? Just multiply by 100. So it will be 2.03%. So it is increasing by 2%. Now how to say whether it is increasing? Because it is inversely proportional. Inversely proportional. If the differential cross section in a scattering is equal to a square, where a is a constant, then total cross section. So what is given here? Here d sigma by d omega is equal to a square is given. This is the differential scattering cross section. Now what is asked? You are asked to find out sigma, the total cross section. So what you have to do, sigma is equal to integral a square d omega. That's equal to integral from where to where? 0 to pi. So integral 0 to pi a square d omega is nothing but 2 pi sine theta d theta. So 2 pi a square will come out because this is a constant. So 2 pi a square into integral sine theta d theta 0 to pi. This value is nothing but 2. Now we'll see that 2 pi a square into sine theta minus cos theta. From where to where? 0 to pi. Cos theta, from since it is minus, we will go with lower limit. So 2 pi a square into cos theta 1 minus cos pi minus 1. That's equal to 4 pi a square. So your option D. So you have to remember this formula, differential cross section formula, and as well as total cross section formula. The center of mass of an L-shaped uniform wire as shown in figure, OA equal to OB equal to L, is at. So this is a problem on center of mass. So let us see, if there was only OB, then center of mass would be at this point, right? That is what is the coordinates on 0, x-axis 0, comma L by 2, right? And now let us see, if only OA was present, here it would be the center of mass. So what is the coordinate of that center of mass? L by 2, comma 0. This is the individual center of mass for each length. Okay, each rod, the center of mass. Now center of mass of the system, center of mass of system, how do you give represent? x center of mass is equal to mass into L by 2 plus another mass into 0 divided by m plus m. This is x coordinate, and similarly you can write y coordinate. Mass into 0 plus m into L by 2 divided by m plus m. Why m plus m? Because these both rod have mass m and both are uniformly distributed mass. Uniformly distributed. So what is xcm? M L by 2 divided by 2m. So that is equal to L by 4. Here m L by 2 by 2m, that is L by 4. So L by 4 comma L by 4 is the center of mass. So your option is B. If the Lagrangian of a mass m is given by, so Lagrangian is given, and you are asked to find out x. So let us write the equation of motion, Lagrangian equation of motion. Total time derivative of dou L by dou x dot minus dou L by dou x equal to 0. Now this is equal to d by dt of, what is dou L by dou x dot? 2 mx dot by 2, that is equal to mx dot minus what is dou L by dou x? Okay, that is equal to f equal to 0. What is total time derivative of mx dot? That is nothing but mx double dot minus f equal to 0. From here we will get x double dot is equal to f divided by m. Now x dot, so what is x dot? Then x dot equal to integral x double dot with respect to time. X dot is nothing but dx by dt. X dot is equal to dx divided by dt. And what is x double dot? D square x divided by dt square. Okay, so x double dot into dt. What is that? F by m into t plus some constant c1, right? Some constant c1. Now we want x, right? So once again you have to integrate this. X equal to integral x dot dt. That is equal to, what is x dot? F by mt plus c1. So integral x dot will be f by m t square divided by 2 plus c1t plus c2. So f by 2m into t square, f by 2m into t square. So option C. A body of mass m moves in a circular orbit of radius r in a potential v of r is equal to minus k by r, where k is a constant. Then orbital angular momentum about the center of the circle. So orbital angular momentum L is nothing but mv into r. Now what is given to us is v. V is equal to minus k by r. What is force? D by dr of v. That is nothing but k divided by r square. Right. So force, but we already know mv square by r is equal to k divided by r square. From this we can take v is equal to, or v square is equal to k divided by mr, or v is equal to under root k by mr. Now what do we want? We want is L is equal to mv into r. Now just substitute this v here. M into what is v? Under root k divided by mr into r. So what you get is under root mkr. Alright. So your option C. Identify the correct Hamiltonian equation of motion from the following. It's a direct question. Q dot is positive, P dot is negative. So this is your option C is your correct answer. So what is Q dot? Q dot, you can, it is not exactly, we do not know, but you can take it as x, a coordinate x. So Q dot will be x dot, which is nothing but v. Just for comparison, I am giving you these ideas. Now what is P? That is nothing but momentum, mv. That is nothing but mx dot. And what is P dot? That is nothing but mx double dot. Okay, so this, what is this? X dot is nothing but velocity, this is nothing but force, right? So velocity and force, just giving you an idea what it is giving you, what do you mean by Hamiltonian equation and what does it give. Q dot is dou h by dou pi, P dot or pi dot is equal to minus dou h by dou k. So please remember this. If the potential energy of a body is given by V of x is equal to x square minus 4x plus 4, the point of stable equilibrium. Now how will you find out this? So what you have to do is find out v dash. So what is v dash? First derivative of v with respect to x is nothing but 2x minus 4. Now v dash, when you equate it to 0, you get stable points. V dash, when you equate to 0, you get stable points. Okay, now v dash equal to 0 implies 2x minus 4 equal to 0, that is equal to x equal to 2. Now you have to verify that at x equal to 2 you have a stable point. Now x equal to 2 you have a stable point, whether it is, x equal to 2 you have an equilibrium point. Now whether it is stable or unstable, we have to find stable or unstable. For that you have to take the second derivative of v, that is nothing but 2x minus 4, 2x minus 4 v dash, that is, so that will be equal to 2, v double dash equal to 2. Now if this value is greater than 0, this is a stable equilibrium. If this value is less than 0, it is unstable. Okay, and in between there is point of inflection also. Point of inflection, not inflation, inflection. Okay, so now you got at x equal to 2 it is a equilibrium point, and now you also proved that that point of equilibrium is a stable point of equilibrium. So x equal to, rigid body consisting of 3 particles A, B and C is constrained such that A and B are rigidly fixed to be at rest. Which of the following statement correctly describes the behavior of C? Actually, behavior of C means path followed. Okay, so on your right side here, A and B is fixed and C is able to move. Now first of all we want to know what is mean by a rigid body. Rigid body is such that all the particles A, B and C, their distance will not change, are fixed. A, B, the distance is fixed, and C to B fixed, and this CA is also fixed. This do not change. And what we can change is its orientation we can change. But here in this case, since A and B are fixed, the orientation of A and B should not change, or it is at fixed position. In that case, what is the behavior of C? C can move in a surface of sphere. No, what is the movement of C can have? It cannot move here. It can move only we can rotate this, right? When you rotate, the C will follow this path, a circular path. So C can move in the circumference of a circle of constant radius with the line joining AB passing normally through the center. See, line joining AB is passing normally through the center. This is the correct option.
Here we have a straightforward question. If a motion of the planet of mass m around the sun with the mass capital M is treated as a two-body problem, then if the t is the time period of revolution and a is the semi-major axis and g the gravitation constant, then exact form of the third law of Kepler. The answer is t square by a cube equal to 4 pi square by g into m plus m. And here with if you have pi square here, this is the simplified form. Okay, this is the simplified form, and option C is the when you are considering the two body problem.
The eigenfrequencies of small oscillation of a system having Lagrangian m by 2 into x dot square plus y dot square minus m by 2 into omega 1 square x square omega 2 square y square. So this is oscillation in two dimension. So let us write what is Lagrangian L my Lagrangian. This first term is nothing but the kinetic energy term. The second term is potential energy term. So m by 2, if you take it out, and this is what is that kinetic energy. This is x dot y dot y dot. In that case, this x dot square, so x dot, so this is x dot square, and there is no x dot y dot term, so this is 0. Similarly, x dot y dot term is 0, and y dot square, that is 1. So this is the equivalent matrix for kinetic energy term. Similarly, we can write it for potential energy term. So m by 2 omega 1, so this is x y. So here you have 1, again here 0 0 1. Now determinant of v minus omega square t is equal to 0. This will give you eigenfrequencies of the system. V minus omega square t, determinant of V minus omega square t. Now here this is your V, this is your t. So V minus, so omega square, sorry, here what we left is omega 1 square. This is omega 1 square, this is omega 2 squared. So omega 1 squared minus
omega square t, omega square t is nothing but here you have only one. So the second quantity, second entry is 0, third entry is again 0, and third one omega 2 square minus omega square, m by 2 outside. Right, now determinant equal to 0 means omega 1 square minus omega square into omega 2 square minus omega square must be equal to 0, which means either this should be equal to 0 or this should be equal to 0. So let us take the first one equal to 0. So the solution will be omega square equal to omega 1 square, which means omega equal to, that means omega x equal to omega 1, omega square along y is equal to omega 2 square equal to omega y is equal to omega 2. So this is it. So what is the answer? Omega x equal to omega 1, omega y equal to omega 2. So option A. So things to remember here is, one is how to find out the eigen frequencies and how to convert this matrix form. This is the Lagrangian, this is the matrix form for kinetic energy and potential energy. Two masses of value m are moving towards each other with equal speeds of value 0.6 c. So here you have mass m moving with 0.6 c, and on the other side you have the same mass m, not the same mass, similar mass m moving with 0.6 c. Okay, they are colliding and they are sticking together and then moving. Okay, now what is the final mass m? Now let us see what is the mass of this m dash when it is moving with point c. So the mass m dash will be is equal to gamma times m, right? Now what is gamma? We don't know, but we are given v is equal to 0.6. now write it in the form of fractions. So 6 by 10 is the value. Now write this, we have seen this shortcut how to find out gamma from v. So write it as 10, that is denominator as the hypotenuse, one side as the one side as 6, then the other side would be 8, then gamma is nothing but hypotenuse divided by side 2. This is side 1, this is side 2. So side 2 hypotenuse is 10, side 2 is 8. So 5 by 4 is your gamma. So first mass m will increase by, so m dash is equal to 5 by 4 times m. Okay, similarly this is also moving with the same speed, so capital M would be is equal to 2 times gamma m, that is nothing but 2 into gamma is 5 by 4 into m, that is nothing but 10 divided by 4 m, that is nothing but 5m by 2. It would be definitely greater than 2 times the mass. So it will be definitely, so all values are greater, so you don't have any other option. In some questions, if you get some idea, if suppose these options were less than 2m, one of, if these options, for example, if this was 3 by 4m and this is 7 by 8m, then even without looking into doing this problem, we can definitely write B, because when a body is moving, its mass is definitely greater than its rest mass. So together mass will be always greater than 2m. This is only one. Okay, so this is the actual method how to follow. Just follow the step by step, and this, please remember this trick how to get the value of gamma from V. Please don't use gamma equal to 1 divided by under root 1 minus V square by C square. You will keep doing this problem. It would take more than 2-3 minutes. Follow these simple methods, tricks to get into this answer. The charge Q is uniformly distributed in a sphere of radius r. The divergence of inside electric field inside the sphere. Now, what do you mean by divergence? Del dot A, where A is a vector. Now, since it is in 3 dimension, let us take r, theta and phi for our convenience. R, theta and phi. Okay. So our function is, or electric field is a function of r, theta and phi. Since it is radially varying and theta and phi are constant, our f is a function of r only. Now A is nothing but AR, that means radial component, plus theta component A theta into theta cap, plus A phi into phi cap. So this is how you can represent a vector in 3-dimensional spherical polar coordinate. Now del dot A is nothing but 1 by r square sine theta dou by dou r square sine theta into AR, that means radial component, plus dou by dou theta r sine theta into A theta, that is the second one, theta component, and dou by dou phi of r into A phi, that is phi component. Now we have already said it depends only on r, so only this much we need to take, others are 0. So del dot A is nothing but 1 by r square sine theta dou by dou r square sine theta into AR. Now sine theta we can take it outside because it is taking derivative with respect to r. We are taking with respect to r, partial derivative. So sine theta it can come out. So del dot A is nothing but 1 by r square dou by dou r square into AR. That means radial component AR. Now, inside a spherical shell, or sorry, spherical sphere, inside the sphere, electric field is given by, electric field is KQR divided by capital R. So this is the formula for electric field inside the sphere. Then just substitute this value here. We want del dot E, that means 1 by r square dou by dou r of r square into K capital Q R divided by capital R cube. So this is equal to 1 by r square, K, Q and R cube you can take it out, K, Q and R cube taken out, R square and R cube, that is partial derivative of R with of R cube, that is nothing but 3R square. So this R square and R square get cancelled. What is remaining is 3KQ by R cube, that is 3KQ by R cube. This is del dot E. So your option A is B. Now one K is missing here. So what you have to remember from this question? What is del dot A in spherical polar coordinate and electric field inside? Electric field inside the spherical or sphere. Okay. Now electric field inside is this much. What is electric field on? Electric field on the sphere. It is, just put small r equal to capital R, you will get kq by r square. Okay. Given below are two vectors. Find out which of them can be magnetic field vector. The best method you can follow is del dot B is equal to 0. This is the Maxwell's equation. So del dot B is equal to 0. Find out in which whether this 1 and 2, when you take the del dot B equal to 0, then that particular vector can be a magnetic field vector B. Okay, so let us write what is del. Del is nothing but I dou by dou x plus j dou by dou y plus k dou by dou z, k cap, j cap, I cap. Okay, so del dot, let us take the first vector. So I cap into dou by dou x of I, that is nothing but 1 plus j cap. So dou by dou y, that is second derivative. It must be, sorry, first that with respect to y z, so that is not equal to 0. So this is not equal to 0. So del dot, your first vector is not giving 0. So first vector is not a magnetic field vector. Now take the second one, del dot second one, 2x with respect to x means 2 plus yj with respect to y means 1 minus this 3 times z means again 1 k cap. So 2 plus 1 3 minus 3. So this is giving you 0. So this can be a magnetic field. So your option is 2 is true. Yeah, 2 is true and 1 is false. Suppose this was xi cap minus zk cap, then this would have been also correct. Or if it was xi cap minus zk cap, sorry, yj cap, then also your answer would have been, for both of them are true. Just check del dot B. At the interface between two dielectric, normal component of electric field satisfied. So what you need is, here in this question, electric field normal component. How do they satisfy the boundary condition? What is the condition imposed on the normal component of electric field? This is what the question. Now when electromagnetic wave move from one medium to another medium, let me call this as 1 and 2. So when they move, these quantities, normal component and transverse component, n represent normal component and t represent transverse component. This one represent the medium. Okay, what are the conditions imposed on these quantities? That is what the question is. Now the boundary condition will follow these relations. The transverse component of electric field are same, equal, and normal component of magnetic field are equal. H2t minus H1t equal to IF by A. This IF is nothing but current, free current, current by area. Now what is H? H is equal to B by mu. Okay. Now d2n minus d1n equal to q by a. What is d? D is nothing but epsilon e, displacement vector. Now what is q? Q is total charge and a is area, that is nothing but sigma. So when you substitute this d equal to epsilon e in a last equation, the fourth one, what you get is epsilon 2 into e2n minus epsilon 1 into e1n equal to q by a, or you can write sigma surface charge density. So your option is option A, the boundary condition on normal component of electric field at the interface. Okay, so please remember these boundary conditions, it is necessary. And for charge free and current free region, this quantity will be 0, then h2t and h1t will be equal, d2n and d1n are equal. A charge q is placed at AB, that means in the first quadrant, between two right angled triangle grounded conducting planes. Between two right angled grounded conducting planes. So this is from method of images. Method of images. That means you are assuming this in image, okay, conducting planes. Then image charges and their locations are. Now here is a conducting plate kept along y, and along x also there is a conducting plate kept. So this y will also reflect, x will also reflect. From due to y mirror on y axis, you will get exactly a point here where that point is y is positive. So q a is x direction, right? So a is minus a comma b plus b, and charge minus, negatively charged. Similarly, due to x, there will be a point here that is in the fourth quadrant. So q, fourth quadrant, q a b. So a towards a, so that is positive, b is negative. Similarly, due to this, here also you will have a charge. So this is also minus, because first reflection minus, second reflection positive. Positive q, it is in the third quadrant, so both are negative, minus a minus b. So look at this, only in this third quadrant it has to be plus, so third quadrant plus, only b, only one option. This also it is. Electric dipole moment of HCl molecule is 1 dB. Now that value of 1 dB is 3.3 into 10 to the power minus 30 coulomb meter. Now the electric field due to this dipole at a distance of 100 angstrom from the center of HCl molecule on the line joining H and Cl ions. Now you have H here, which is positive, and here you have Cl minus. So this is acting as a dipole. Okay, now the dipole moment is given as P. Dipole moment P equal to this much value, 1 dB. Now the question is, from this way, from the center of the line joining H and Cl ions at a distance r equal to how much, 100 angstrom, you have to find out the electric field. Now once for a dipole, once the dipole moment P is given, what is the electric field axial? Axial is 2p
divided by 4 pi epsilon naught r cube. If it is equatorial electric field is just the half, P divided by 4 pi epsilon naught r cube. Now here everything is given. We just have to substitute values. So E axial equal to 2 times P. P value is 3.3 into 10 to the power minus 30 divided by 4 pi epsilon naught into R. R value is 100 angstrom whole to the power 3. Now this 1 by 4 pi epsilon naught you can take it as unity. Then what you are getting is, here you will get 6.6 into 10 to the power minus 30 divided by 100 cube is nothing but 10 to the power 6 angstrom 10 to the power minus 10 whole to the power 3. So 10 to the power minus 30 and 10 to the power minus 30 gets cancelled. What it is remaining is 6.6 into 10 to the power minus 6 in terms of coulomb meter square, because r square comes in the denominator, r cube. This much is the value. So which is the correct option? Option C. Leonard Weightage potential R. So few options are there. So here you are given the potential, that is, this is scalar potential and this is vector potential. This is Leonard Weightage potential for equations for scalar and vector potential. Now of what? It is of a moving point charge. Okay, now relativistic effect is included. In this equation, relativistic effect, but not quantum effect. Quantum effect is not included, but relativistic effect is included, because this beta s is nothing but v velocity by c. Okay, fraction of velocity. This is called fraction of velocity. Beta term is nothing but fraction of velocity at which the particle is moving. Okay, so your option is D. It is indicating scalar as well as vector potential due to moving point charge. One thing you have to remember, even though relativistic effect is included in this formula, quantum effect is not included. That is a classical approximation. Electric field associated with two electromagnetic waves are in the ratio 3:2. Then the energy transported per unit area. So energy, what is the formula? Energy is equal to epsilon naught E square by 2. This total energy, that is due to electric field. Okay, so total energy is nothing but epsilon naught E square, only that much, no by 2. So that is total energy. This is energy due to electric field. So energy due to magnetic field is nothing but same, epsilon naught T square by 2, but we will write in terms of magnetic field, epsilon mu naught B square. Now what is the question? Electric field, what is the ratio of the energy transported? So it is proportional to, energy is proportional to E square, energy proportional to E square. So 3:2, so 3:2 whole square, so that is 9:4. So your option
if the electric and magnetic vectors of plane electromagnetic wave are along, these are the directions of vectors, that is, let us take it as electric field vector and this will be magnetic field vector. And the question is, the propagation vector is along which direction? Now, direction of propagation for electromagnetic wave, direction of propagation is along energy transfer, right? In which direction energy is transferring, in that direction electromagnetic waves will move. For example, if waves is moving in this direction, energy is in this direction, right? Now, transfer of energy, take which vector gives you? That is nothing but Poynting's vector. Poynting vector. Okay, Poynting vector S is given by E cross H, where H is nothing but magnetic field intensity. So you can take E cross B because H and B are in the same direction. So E cross B, if you take, you get S, I mean the direction, not S, just the direction. Alright, now what is that? Write it as IJK root 3 by 2 1 by 2 0 minus 1 by 2 root 3 by 2 0. Now since k is 0, I and j component will be 0, right? I 0 plus j 0. Why? Because kth component in both E and B is 0. So k cap into root 3 into root 3, that is 3 by 4 minus 1 by 2, this minus this, so minus 1, so plus 1 by 4. So that is in the direction of k. So your answer is C. A dipole of dipole moment P is placed in an electric field E is equal to E naught x cap. Then the force experienced by the dipole. Force experienced by dipole means both the charge. Now here electric field is in this direction. Okay. Now here you have positive Q and here negative Q. Now this is what is dipole is. Now what we have to remember here is your electric field is not uniform. Okay. Now if this electric field was uniform, then your total force on this dipole will be equal to 0. If the electric field in which the dipole is kept is uniform, then total net force on this dipole will be equal to 0. But the point here is E depends on the position. Electric field depends on the position. Now this is 0. As you go along this x-axis, what happens is electric field will increase in this way, E naught x cap, E naught into value of that x coordinate, point in the x coordinate, and I cap. Now here when you come towards the negative region, that means towards the left, you have E naught minus x into I cap. So this is the electric field at this point. Okay, that means at minus q your electric field is this, and at plus q your electric field is E naught x cap. Now what is the force here? Force is equal to electric field into charge. Now what is the electric field? E naught into x into I cap, that is the electric field, into q. So E naught x q I cap. I cap means it is in the positive direction. So this is the force direction. Now look at this particular
charge, that is minus q. That what is the force here? Force is equal to E naught into minus x, E naught into minus x into what is the charge? Minus q. What is the direction? I cap direction. In the I direction. Now this is nothing but E naught x q in the direction of I. Now this is experiencing a force equal to F1, or let me write it as F minus. This is experiencing a force F plus. Okay, so F plus is in positive x direction, positive I direction. F minus is also in the positive x direction. So together net force is equal to F plus plus F minus, which is equal to E naught x cube, E naught x cube plus E naught x cube, both are in the same direction, so I. So that is equal to 2 times E naught x into q. Now 2x cube, that is nothing but dipole moment. 2x q equal to p. So what is the, there is I cap also, you can write. So what is the net force? That is equal to px, that means the direction is x, that is the indication of px, into E naught into I cap. So this is the net force. So that's your answer.
Before getting into this question, if there is a current carrying wire of some length, finite length, let me call this AB, and angle made by A and B to this point is alpha and beta. I want to find out the magnetic field at this point. Now that magnetic field at that point is given by B is equal to mu naught I divided by 4 pi r, the distance from the wire to that point, into sine alpha plus sine beta. Okay, so this is the formula for finding the magnetic field. Now here, if this wire is being extended to one end, that means this A end is being extended to infinity, that means this alpha is tending to 90 and beta value will be very small, so we will neglect. So if it is extending to one end, alpha value is 90, so sine alpha is 1, so your magnetic field will be equal to mu naught I by 4 pi r. Now suppose it is extending to both sides to infinity, so sine alpha also will be equal to 1, sine beta also equal to 1, so then magnetic field will be equal to mu naught I divided by 4 pi r into 2, because sine alpha plus sine beta, so that is nothing but mu naught I divided by 2 pi r. Now here the question is very similar. Here alpha is value is 45, beta value is 45, so sine alpha is 1 by root 2. So just let me write the magnetic field, mu naught I divided by 4 pi. What is the r? The distance r is nothing but a by 2, right? So a by 2 into sine alpha plus sine beta. Sine alpha is 1 by root 2, so 1 by root 2 plus 1 by root 2. Okay, so what is that? 2 divided by root 2, so mu naught I by 4 pi a into 2, this is going up, into 2 divided by root 2.
Now this is for one side. How many such sides are there? 4 sides are there. So multiply by 4. So this 4 and this 4 get cancelled. Root 2 gets cancelled. So this becomes, so finally our answer is mu naught I by pi a, mu naught I divided by pi a into 2 root 2 into 2 root 2. So 2 root 2 mu naught I by, so pi is missing here. So pi, so your option is C. Energy eigenvalue of a particle of mass m confined to a one-dimensional box of length L. Now, what is the formula? It's a direct formula. Energy eigenvalue is equal to n square pi square h cross square divided by 2m L square. So your answer is C. Now for this is one-dimensional box. For two-dimensional box, nx square plus ny square into pi square h cross square divided by 2m L square. Now this is true only if your length, two dimension length Lx equal to Ly equal to L. Suppose if the length is not correct, same, what you have to do, nx square pi square h cross square divided by 2m Lx square, that means length along x-axis, plus ny square plus, sorry, ny square pi square h cross square divided by 2m Ly square. For 3 dimension, nz square pi square h cross square divided by 2m L square. Nx, ny and nz are the respective states. Okay. The ratio of wave numbers of first Balmer spectral line of hydrogen atom to that of the second Balmer line. So what are the lines? Lyman, Balmer, Passion, Brack and P. That is actually fund, P fund. Okay, remember it like that. Now Lyman n value 1, Balmer for 2, 3, bracket and fund for 5. So n means nf, final state. So how will you find out wave number? Wave number 1 by lambda is equal to r naught Rydberg constant into 1 by nf square minus 1 by ni square. Now about which line they are talking about? Balmer. So nf is equal to 2. So 1 by lambda r naught into 1 by 2 square minus 1 by 3 square. So this is the first Balmer line. Second one will be r naught into 1 by 2 square minus 1 by 4 square. So this will be second. Third one will be 1 by 2 square minus 1 by 4 square into r naught. And the question is the ratio of this 1 by lambda to this one. Okay. So this is 9 minus 4, that is 5 by 36. So that is equal to 1 by 9 minus 1 by 4 minus 1 by 9, that is equal to 9 minus 4 divided by 36, that is equal to 5 by 36. Now 1 by 2 square, that is 4, minus 1 by 16, that's equal to 16 minus 4, that is equal to 12, divided by 4 into 16. Now this quantity divided by this quantity. So 5 by 36 divided by 12 divided by 4 into 16. So that's equal to 5 by 36, 4 into 16 divided by 12. Okay, 6 times you can write it as 4. This is 3. Right. So this again 1. This is 9. So 5 into 4, that is 20, divided by 9 into 3, that is 27. So this is the answer. But none of the answers here, it is given as hash, so answer is not given in the option. But this, if it was Lyman series, Lyman series of 1 and 2, first and second Lyman series, the ratio of wave number of first and second Lyman series, instead of it Balmer, if it was Lyman, you would have got this answer B. Okay, 27 by 32 you get. It was for Lyman series for 1 and 2. But for this Balmer series, for first and second line, it is 20 by 37. The probability current density for psi of R is equal to e power ikr divided by R, where k is a real constant, and this probability current density has a magnitude. So they are asking about probability current density. Now what is the formula? If psi is equal to e power ikx, then probability current density, that is J, is equal to magnitude of A whole square into h cross by m into coefficient of ix, that is k. So what we have, according to the formula, h cross k by m, what is magnitude of this A? That is nothing but 1 by r whole square. So that is equal to h cross k by m r square. So h cross k by m r square. So B is your answer. 1, 2 and 3 denote set of mutually orthogonal state. Okay, now so these are different states, mutually orthogonal. Okay, norm of the state, norm means n, value of n. Psi is given by norm of the state for psi. So a combination of 1, 2 and 3 is given. So A into 1 plus B plus IC into 2 minus I into ID into 3. The state, third state, first, second and third. So our wave function or the particle is in first state, second state and third state in this proportion, A, B plus IC and minus ID. Now we know psi, this is nothing but psi star psi. Okay, psi star psi must be equal to 1. That means the coefficient of first state, that is A square, plus square of the coefficient, that means square of the coefficient of first state plus square of the coefficient of second state. What is that? B plus IC, that is nothing but B square plus C square. plus d square must be equal to 1. So what is the norm then? Norm is nothing but under root a square plus b square plus c square plus d square. Now why b plus ic is whole square is b square plus c square? B plus ic into b minus ic. This is what is more multiplied. Psi star psi. When you have to multiply by psi star means complex conjugate. This is complex number, this is its complex conjugate. For id also you have to take the complex conjugate. For minus id, complex conjugate is id. So minus id into id is nothing but d square. This is nothing but b square plus c square. It will be like a square minus b square, a square minus b square, right? A plus b into a minus b. So a square minus b square. What is b? So I square will come. I square is nothing but minus 1. So b square plus c square. So norm n is, that means what do you mean by norm? You have to divide while normalizing. You have to divide this quantity psi divided by this particular quantity, then you will get psi star psi equal to 1, just to make the probability equal to 1. So this is our commutator. Let us first simplify it as writing as a function of x, taking that x. So x cap into x comma px square plus x comma px square into x cap. So this is how we expanded. So x cap into x comma px is nothing but IH cross, and x comma px square is nothing but 2px, that is derivative of px square with respect to px, plus x cap into x cap comma px square is that is nothing but IH cross into 2px. So IH cross into 2px into x cap. Now you see this IH cross and 2 is common. Take that common out. 2i h cross into x cap into px cap plus px cap into x cap. So option C. Same way you can use this x square also. How? So x square comma px into px plus px into x square comma px, right? So x square px, that is IH cross into the derivative of x square, that is 2x cap into px cap plus px into x comma px is nothing but IH cross, the derivative of x square, that is 2x cap. So IH cross into 2, that is common. So 2i h cross into x cap px cap plus px cap x cap. Both way you can get the same answer. Okay, again there is more difficult methods, lengthier methods. You can consider even px square as a function of x and then, but this would be fine for you. Now trace of a matrix alpha x, beta and alpha x, where alpha x and beta denote Dirac matrices. Now these are sigma x, sigma y, sigma z. These are Dirac matrices. Now you see in all these matrices your trace is 0. Sum of the diagonal elements is 0. Okay. Now properties of this Dirac matrices are sigma x square is equal to, you are getting an identity matrix. Similarly, sigma x square equal to sigma y square equal to sigma z square. These all are identity matrix. Now coming to the question, alpha in x into beta. Just take any two matrices and make a product. Sigma x into sigma y. Just see 0 1 1 0 multiplied by 0 minus I 0. Okay. And what about the determinant? Determinant of Dirac matrices is equal to minus 1 for all. Determinant is equal to minus 1 and a trace equal to 0 for Dirac matrix. So 0, what, that is I, again 0, again 0, minus I. So this is one product into the same matrix sigma x, that is this matrix 0 1 1 0. So 0 1, right, 0 0, so 0 and I, then minus I, then again 0. Now what is the trace here? Again trace again here is 0. Even in this product, first product, trace is equal to 0. So your product trace of this matrix alpha x beta alpha x is 0. Option A. Let psi of x be an arbitrary wave function of a physical system and h be the Hamiltonian of the system with lowest eigenvalue denoted by E naught. Now how to find out energy? Energy is nothing but integral psi star h psi dx divided by integral psi star psi dx. Now the denominator is nothing but probability, and psi star h psi dx, this is how you find out energy, expectation of energy or expectation value of h. So this is nothing but psi star h psi divided by psi star psi. This is the minimum energy equal to E naught. That means this particular quantity can be greater than or equal to E naught. So your option is option D. A quantum system is in the state 1 by 2 into phi 1, 1 by root 2 into phi 2, 1 by 2 into phi 3. Okay. Now I is 1 2 3, these are the states, okay, are orthonormal states. And what's the question? The probability amplitude for the system to be in state. The probability amplitude is nothing but psi mod psi or psi 1 mod psi 2. Now this is your wave function psi. Now this is your another wave function psi. Let me call it as psi 2. Probability amplitude is means this one. Okay. Now first of all we have to check the psi 1, that is this state is normalized. If it is not normalized, we have to normalize. Now how to check whether it is normalized? square of the coefficient must be equal to 1. Square of coefficient equal to 1. So let us see, 1 by 2 squared plus 1 by root 2 squared plus 1 by 2 squared equal to, this is 1 by 4, this is 1 by 2, this is 1 by 4. 1 by 4 plus 1 by 4, this is 1 by 4 plus 1 by 2 plus 1 by 4. Half plus half, that's equal to 1. So this is normalized. Okay, now if it is not normalized, if you have some another value 2 or 3, what you have to do, you just have to divide it by 1 by root 3. Okay, or multiply by 1 by root 3. Now this is fine, our wave function is normalized. Now take this value, so 1 by root 1 by 2 phi 1, you have to see phi 1 and phi 3. So 1 by 2 phi 1 plus 1 by 2 phi 3, okay, into 1 by root 2 phi 1 plus 1 by root 2 phi 2. Now I have avoided removed this, didn't consider, because there is no phi 2 state here, it is independent of phi 2. So 1 by 2 into 1 by root, so 1 by 2 root 2 plus 1 by 2 into 1 by root 2, that is 1 by 2 root 2, and phi 1 is nothing but 1. Okay, it is just like row and column multiplication. So 1 by root 2 plus 1 by root 2, 2 by 2 root 2. So what is left is 1 by root 2. So your answer is B. Which of the following is a possible eigenvalue of the operator Lx square plus 3Ly square plus root 3 into Lx Ly plus Ly Lx? So on your right hand side, what you're seeing is expectation value of Lx square, Ly square and Lx Ly. So expectation Lx square is nothing but h cross square by 2 L into L plus 1 minus m square, and similarly this is Ly squared equal to h cross square by 2 into L plus 1 minus m squared. Both are same. Lx square is equal to Ly square expectation. Now coming back for L equal to 1 and m equal to 0. What are, if L equal to 1, m will be equal to 0. Then what is Lx squared? Expectation Lx squared will be equal to h cross squared by 2 into L plus 1 is 1. Now similarly Ly squared will be is equal to, this is 2, h cross squared by 2 into L plus 1 is again 2. So this is equal to h cross square, this is again equal to h cross square. So here you can write this expectation value is equal to h cross square plus 3 times h cross square, which is nothing but 4h cross square. This quantity will be equal to 0. This one, expectation of Lx Ly and Ly Lx. So your answer is 4h cross squared. So please remember these values: Lx square expectation, Ly square expectation, and Lx and Ly. A two-level quantum system has an energy eigenvalue E plus minus is equal to plus or minus under root E naught square plus E1 square. So here we have a quantum system which has eigenvalues this. So let me write lambda 1 is equal to plus under root E0 squared plus E1 squared, and lambda 2 equal to minus under root E0 squared plus E1 squared. Now the determinant of the matrix will be equal to lambda 1 times lambda 2, which is equal to minus of E0 squared plus E1 squared. Okay, so our matrix formed by this quantum system has a determinant minus of E0 square plus E1 square. Then trace of that matrix will be equal to lambda 1 plus lambda 2, which is equal to 0. So now the question is, this matrix is written in terms of Polish matrices, that means sigma x, sigma y, sigma z, and the identity matrix I. Which of the following does not correspond to Hamiltonian of the system? So this matrix, whatever matrix this gives you, H, should have a determinant equal to this particular value and trace equal to 0. So let us see the option one by one. In the first option, you have H is equal to E0 into sigma x minus E1 into sigma z. E0, this is sigma x minus E1 into sigma z, which is equal to this minus E1, E0, E0 and E1. Now what is the determinant of this particular matrix? Determinant equal to minus E1 squared minus E0 squared, which is equal to minus of E0 squared plus E1 squared. Now take the second Hamiltonian. So this is true, and let us check what is trace equal to. Trace of this matrix is equal to E1 plus minus E1 plus E1, that is equal to 0. Okay, so your option is A is correct. Now check the option B. H equal to E0 times sigma y plus E1 times sigma z, which will give you E1 minus I E0 plus I E0 minus E1, which is equal to E1, that is equal to minus E1 squared minus of I and I into I is minus 1 into minus 1 is equal to plus, so minus again E0 squared, which is equal to E0 plus E1, E0 squared plus E1 squared with a minus sign. And similarly here the trace E1 minus E1, trace is again equal to 0. So your option B is also correct. Now check the option C. H is equal to E0 into sigma y plus E1 into sigma x. E0 into sigma y plus E1 into sigma x. So 0 minus I E plus E1 minus I E0 plus E1. Now here trace is sum of this diagonal element, which is equal to 0. Determinant is 0 minus E1 minus I E0, E1 plus I E0 into E1 minus I E0. A plus B into A minus B, that is equal to A square minus B square. I will get squared, so what you are getting is minus of E0 squared plus E1 squared. Again your determinant is same, so option C is also correct. Now check the option D, which is H is equal to E0 times I, identity matrix, plus E1 times sigma z. E0 times sigma I plus E1 times sigma set. This is what you are going to get. Here the trace is equal to E1 and E1 gets cancelled and E0 will remain. E0 will remain 2 times E0. 2 times E0. And what about the determinant? Determinant will be E0 plus E1 into E0 minus E1. So E0 squared minus E1 squared. So this is not true. So so the option D is the correct option, which does not correspond to the given matrix. So this is option D is the correct one. All others give you the same eigenvalues. Three-dimensional harmonic oscillator is in thermal equilibrium with heat bath at a temperature T. The average total energy of the oscillator. If the total kinetic energy was asked, kinetic energy is equal to half kBT. Then for this is for one dimension. For 3 dimension it is 3 by 2 kBT. This is only kinetic energy. Okay. Now what about total energy? Total energy is nothing but twice that of the kinetic energy. So which is equal to 2 into 3 by 2 kBT. So that is equal to 3 kBT. So kB same K, Boltzmann constant. So your option is B. Number of ways in which 5 identical bosons can be distributed in 4 states. Boson. For boson, the distribution function W or omega is given by Ni plus Gi minus 1 whole factorial divided by Ni factorial into Gi minus 1 factorial. And where this is Ni is number of particles and Gi is number of states. This is the same question repeated from 2018. Same question. Now, so what is Ni here? Ni, number of particles, 5. So Ni equal to 5. Gi equal to 4. Right. So Ni plus Gi minus 1. That is 8 factorial divided by Ni factorial. What is Ni 5 factorial? Gi minus 1 is nothing but 3 factorial. So 8 factorial by 5 factorial into 3 factorial. So your option is D. So please remember this formula from this equation. For bosons, the distribution function omega given by Ni plus Gi minus 1. So number of ways it can be distributed given by Ni plus Gi minus 1 factorial divided by Ni factorial into Gi minus 1, where Ni is number of particle and Gi is number of states. Equation of a state of gas with internal energy U is given by PV equal to 1 by 3 U. The corresponding equation for adiabatic process. So we know PV raised to gamma equal to constant. So our aim is to find this gamma. Okay. Now from this equation PV equal to 1 by 3 U, we can write 3 times PV equal to U. So this is your first law thermodynamics says dq equal to du plus dw. Now for adiabatic process, your change in heat is nothing but 0. So du plus dw equal to 0. Now what is du is nothing but 3 times PV. dw is nothing but pdv equal to 0. Now that is equal to 3 times PdV 3 times VdP plus PdV equal to 0. So that's equal to 4 times PdV plus 3 times VdP equal to 0. Now dividing by PV, what you are getting is 4 by P 4 by V into dV plus 3 by P into dP equal to 0. Now again you can divide by 3 here. So what you are getting is 4 by 3 times dV by V plus dP by P equal to 0. Now you integrate this value. So integrating, you will get, instead of 0 you get constant of integration. Right. Now leave that part. So that is 4 by 3 times integral dV by V is nothing but log V plus this term is log P. Since these two values are in terms of log, we will write this constant also as a function of log C. So this is log V plus log P. Now we can write it in terms of, this is nothing but log V 4 by 3 plus log P equal to log C. So this we can write it as product, log of the product. So log of V log A into log of A into B. Okay. So log V by V power 4 by 3 into P equal to log C. Now you write it as P V power 4 by 3 equal to constant. Cancel out this log on both sides. So PV power 4 by 3 equal to constant. So what is your answer? Your answer is C. Now, but you need not do all these things, because your gamma value is given by 1 plus 2 divided by F, where F is the degree of freedom. Now this quantity gamma is always greater than 1. It can never have a value less than 1. Now there is only one option which is giving you gamma value greater than 1, that is option C. So you need not do all these things, you just need to know what is gamma. Gamma value can never be less than 1. It will be always greater than 1, because F is degree of freedom. Degree of freedom cannot be negative. So this particular quantity gamma is greater than 1. So from there also you can pick option C. 48th question. Suppose we have two non-interacting identical bosons, both of the mass m, in one-dimensional infinite square well potential of this is the range of the square well potential, and the wave function, you are asked to find out the wave function when one of them is, that is one of the particle is in ground state and the another particle is in first excited state. Now see, this is the wave function of first excited state, this is ground state. Now what are the possible ways? Either the first particle is in the ground state and the second particle in the first excited state, or the first excited state is having the second particle and the ground state ground state is having the second particle and first excited state is having the first particle. So these are the only possibility. Okay. Now, so what is psi? Psi 1 is equal to under root 2 by length of the box. What is that? Is a sine of n pi x by a. Since it n equal to 1, pi x divided by a. This is psi 1. What is psi 2? Under root 2 by a sine n equal to 2. So 2 pi x divided by a. So this is psi 1 and psi 2. So here, since bosons are present, bosons total psi is equal to symmetric. The total psi must be symmetric. That means a wave function psi has two forms. Either it is psi space or psi spin. Okay, together psi space and psi spin must be symmetric. That means if the psi space is symmetric, psi spin also must be symmetric. Or if psi space is negative, that means anti-symmetric, psi spin also must be anti-symmetric. So plus into plus you get plus, that is symmetric. Minus into minus you get plus, that is symmetric. That means together it must be symmetric. Now here the question is incomplete because one of the state must be given. One of the state of either psi space or psi spin must be given. Only then we can find out the other one. Now here psi spin must be given because whatever is in the option, it is about psi space. Okay, if the psi spin is symmetric, then your psi space also must be symmetric. Symmetric means you have to use this formula. If psi spin was anti-symmetric, that is minus, then your psi space must be again anti-symmetric. Okay, so then you have to use this formula. So here this is psi space plus, that is symmetric. This formula you have been using. This is for anti-symmetric. So it depends on the value of psi spin. If psi spin is symmetric, then your option is C. If psi spin is negative, then your option is D. Okay, so from this question we can't say, because either of this psi spin should have been given. So option, it is given in the answer key as C, but D is also possible answer depending on the psi spin. The partition function for a photon gas is given by log z is equal to pi square by 45 into V into kt whole cube divided by h cross cube c cube. The internal energy or the average energy. This internal energy is given by U is equal to minus dou by dou beta log z, or in terms of temperature kt squared into dou by dou t of log z, where beta is nothing but 1 by kbt. Kb is Boltzmann constant. Now, so here it is written given in terms of t. Our function log z is a function depending on t, so we can take the second equation. So u equal to kt squared into dou by dou t of log z. This together is given, log z. Partition function is z. What you need in this equation is log z. So here log z is given. So log z is nothing but pi square divided by 45 into V into kt whole cube divided by h cross cube c cube. Now we can take all the constant outside. So kt squared into pi square divided by 45 vk cube divided by h cross cube c cube into dou by dou t of t cube. So that's equal to kt squared pi square divided by, this is 45 into vk cube divided by h cross cube c cube into 3t square. Alright, so here you have k, so k power 4, t power 4, so kt whole power 4. Okay, then pi square divided by this is 3 and this is 45, so that is 1 by 15, and we have pi squared, this is pi squared v by h cross cube c cube into v divided by h cross cube c cube. So your answer is D. The average energy of an ensemble of gas molecules in equilibrium is given in terms of partition function Z by, similar question, internal energy is equal to U equal to, or sometimes it will be written as U bar to indicate average, minus dou by dou beta log Z. This is in terms of beta. If your Z is a function of beta, you can use this formula. Now suppose your Z is a function of temperature, then use this formula. Now beta is equal to 1 by kBt. Now dou beta is nothing but minus 1 by kBt squared. Okay, so kBt squared into dou t. Now just substitute here dou beta here. What you are getting is, so let us substitute that, minus dou by dou beta log z is equal to minus dou by, instead of dou beta we will write minus 1 divided by kBt squared into dou t. That is nothing but minus minus get cancelled, so kBt squared into dou by dou t. This is the log z, here also log z. So this is how you get two different equations for internal energy. This is Kb, Boltzmann constant. A random walker travels along one-dimensional discrete lattice. So minus n plus 1 extra up to 0 and again extra up to n. By putting random steps of length 1 unit. So from 0 to 1 it is 1 unit. Okay, towards left or right. So the random walker has two probability, either left or right, forward, backward. If the initial position is 0, then the probability of finding the walker at 0th position in 6th step is, that means total number of steps he is taking is 6. And what is the probability of finding the walker at 0th position? That means effective step is nothing but where the position is 0. That means he is not taking any steps. That means effective step is 0. Now what is telling is, a person is standing at A, the random walker. He is taking some steps back and forth towards the positive direction and negative direction, or towards left or right. Then after taking n steps, forward and backward, he is in the same position, 0th position. So initial position is 0. Let me call it as A as 0. Then after taking n steps also, or let me write in terms of this question, after taking 6 steps, the walker is at 0th position, which means what? If he has taken 3 steps forward, he should take 3 steps back. Okay, now coming to some ideas about random walk. If n1 is the number of steps forward, let me, instead of forward, you can write, with respect to this question, you can write it as towards right. n2 is the number of steps backward, this is towards left. Then total number of steps is nothing but n1 minus n2, which is equal to m. So net steps equal to what? 0 with respect to this question. Now what is the total number of steps? n1 plus n2, which is equal to capital N, which is nothing but 6. That means after taking 6 steps, the net steps taken is 0. Now the probability of reaching destination which is m step away by taking n step. That means total number of steps he has taken 6. The effective step is 0. He is m step away. How much? M equal to 0. Then the probability Pn of m. What do you mean by Pn of m? Probability of reaching the destination which is m step away by taking n step, capital N step, is capital N factorial by n plus m by 2 factorial into n minus m by 2 factorial into 1 by 2 whole to the power n. So that is equal to, what is n? 6 factorial. 6 factorial divided by n plus m. M is 0 here. So 3 factorial into 3 factorial into 1 by 2 whole to the power 6. So this is nothing but 6 factorial by 3 factorial, that is 4 into 5 into 6 divided by 3 factorial is nothing but 1 into 2 into 3 into 1 by 2 whole to the power 6 is nothing but 1 by 64. Digital electronics. Okay, so this is 2 into 3 and 6 gone. So 20 by 64. Your answer is 20 divided by 64 divided by 4, 5. Sorry, 4 you will get 5 divided by 16. So your option D is correct. So please remember this formula from this question. Probability of reaching the destination which is m step away by taking n step is n factorial by n plus m by 2 factorial into m minus n by 2 factorial into 1 by 2 whole to the power n. Now when m equal to 0, this probability is maximum. Maximum probability is when m equal to 0. Which of the following gives statistical definition of temperature in terms of microstate omega? Now a system is said to be in equilibrium when it has attained thermal equilibrium, mechanical equilibrium as well as chemical equilibrium. Thermal equilibrium means temperature is constant. Temperature, or you can also write beta constant. Beta means 1 divided by kBT. So this is how you test the thermal equilibrium. Beta equal to dou by dou E of log omega. That is nothing but 1 divided by kBT. So 1 by T is equal to kB times dou by, instead of E you can write U log omega. That is, U is nothing but energy. So from the question, your option A is correct. Now for mechanical equilibrium, you can write eta, that is equal to dou by dou V of log omega. This is to test mechanical equilibrium. And this eta is equal to pressure by kBT. Pressure by kBT. This is for mechanical equilibrium. Now for chemical equilibrium, you can write zeta equal to dou by dou n. Dou by dou n. N is number of particle of the state, and log omega. Dou by dou n of log omega. And eta is given by, eta is equal to mu by kbt. So beta equal to 1 by kbt, eta equal to p by kbt, and zeta equal to mu by kbt. And what is mu here? Mu is chemical potential, and p is nothing but pressure. So these are the different standards for measuring equilibrium: thermal equilibrium, chemical and mechanical equilibrium. If omega denotes number of microstates and V and U are volume and internal energy, then which of the following gives statistical definition of pressure? Now we have already discussed eta. So what it will give? It will give the mechanical equilibrium. Mechanical equilibrium. Okay. So mechanical equilibrium, eta equal to dou by dou V of log omega. Now you can substitute for eta. What is eta from this equation? Eta equal to P divided by kBt. So P by kBt equal to P by kBt equal to dou by dou V of log omega, or you can write P is equal to kBt times dou by dou V of log omega. So what is your answer to P? Kt times dou by dou V of log omega. So your option D.
A photon gas with internal energy U is described by the following equation of state. Now on the right hand side, what you are seeing is the thermodynamic state functions for black body photon gas. Okay, so internal energy is proportional to T to the power 4, particle number is proportional to T cube, and chemical potential is 0. Pressure, or you can write PV, is equal to 1 by 3 U. Entropy is 4U by 3T, and it is proportional to T cube. Enthalpy is 4 by 3 U. Okay, Helmholtz free energy is A equal to minus 1 by 3 U, and Gibbs free energy is 0. Now from the question you can write this, you can take this here, pressure. So P is equal to 1 by 3 times U by V, or you can write PV is equal to 1 by 3 U. So your answer is option A.
An ideal gas undergoes isothermal expansion. The entropy of the system is given. So this is your PV diagram. This is V1 and this is V2. So volume is increasing. Now from first law of thermodynamics, first law, dq equal to du plus dw, and what is dq? dq is tds, du is ncv dt, and dw is pdv. Now since it is isothermal expansion, isothermal process, your internal energy, change in internal energy equal to 0, because change in temperature equal to 0. So you can write our first law of thermodynamics as dq equal to dw, or you can write tds is equal to dw, or ds is equal to integral, or dw divided by t. Okay, now you want entropy. Entropy S is equal to integral dw divided by t. Okay, now that is nothing but work done divided by time, sorry, temperature. So entropy equal to work done by temperature. Now work done in isothermal process is given by work done equal to nRT log V2 by V1 or V final divided by V initial. Okay, so what is entropy? Entropy is nothing but work done by temperature, that is nR log V2 divided by V1. This is what your answer is, nR log V2 divided by V1. This is the change in entropy. So please remember these equations from thermodynamics and as well as the work done in isothermal process.
Here you have the 56th question, that is, if a PN junction is formed having a junction potential Vj and depletion region width W, that is width of the depletion region, then which of the following is true? That means we have to find the relation between the junction potential and the depletion region. Now the equation is given by W is equal to 2 epsilon by Q into 1 by Na plus 1 by Nd into Vbi. Now what is Na is? Na is the doping concentration. Doping concentration on acceptor side, okay, acceptor side, and Nd is doping concentration in donor side. Okay, yeah. Then Vbi is the barrier potential. Okay, fine. So here we can write W is equal to root of, so junction potential we need to know, so that is Bi root of Vbi, barrier potential. Now since W is proportional to root of V, we can write V is proportional to W square. So which of the following is giving you the answer? C. That means Vj is proportional to width square. Fine. Question number 57. Now let us understand the each term given in this question. So op-amp has a amplifier has a gain of 10. So this is closed loop gain ACL, which is equal to 10, and the corresponding frequency, that is we will represent it by F2, is equal to 1 megahertz. Okay. Now there is a quantity called gain bandwidth. Gain bandwidth, which is denoted by the letter GBW, which is given by GBW is equal to the gain times gain into the frequency F2. So what you are going to get is GBW equal to gain into F2. Gain is nothing but 10 into 1 megahertz, the frequency megahertz. So that's equal to 10 megahertz. So this is the gain bandwidth, or it is also represented by F unity. Okay, somewhere you may find it as F unity. This is a constant quantity. That means this GBW and F unity is a constant quantity. Now you are asked, the second part of the question says, what will be the gain if the bandwidth is 10 megahertz? That means what is 10 megahertz? Now this becomes f2, and you are asked to find out the gain, ACL, closed loop gain. Now from this equation, that this is let us put it as equation 1. From this equation you are asked to find out gain, right? So gain, which is nothing but ACL, that is closed loop gain, is equal to GBW divided by F2. Now what is GBW? That is nothing but our F unity divided by F2. Now what is F unity? We have found out it is 10 megahertz. And what is the frequency? The new frequency is 10 megahertz. So this is 10 megahertz. Now what is the answer? 1. So at 10 megahertz your gain will be equal to 1. So ACL equal to 1. So your option A is 1. Question number 58. A square wave of peak to peak amplitude of 500 milliwatt has to be amplified to a peak to peak amplitude of 4 volt with a rise in time of 3 microsecond or less. The op amp used should have a minimum slew rate of. Now let us understand what is slew rate. Slew rate is the measure of how fast the output voltage changes with respect to time, and this is given in terms of volt per microsecond. Usually volt per microsecond is the unit given, or volt per time. Now that means from here in this question you have 500 millivolt to 4 volt. This is the idea, that is 500 millivolt is nothing but 0.5 volt to 4 volt. Now what is the slew rate formula? V2 minus V1, that means the final voltage minus the initial voltage by time. So V2, that is the final voltage, is 4 volt minus initial one is 0.5 divided by what is the time taken, that is 3 microsecond. So 4 minus 0.5, that is 3.5 divided by 3 microsecond, this is 3.5 volt. So it will be almost 1.1 volt per microsecond. This is your answer. So option D. Question number 59. The first order low pass filter has a band pass gain of 10 and the cutoff of 10 kilohertz. The gain of the circuit at 100 kilohertz in decibel is given by which of the following options. Now before going to the question, let us understand a few things. Here you have the frequency response curve. On x-axis you have the frequency, and on y-axis you have the gain in decibel. Now how is gain in decibel given? Gain in decibel is given by 20 times log to the base 10 of AV, that means the gain, general gain. Okay, now from the question we have the gain is equal to 10 gain in decibel is given by 20 log
V base 10 of 10, that is nothing but 20. This is 20 decibel. So this point is 20 decibel. Fine. Now at 1 by root 2 times the voltage gain, 1 by root 2 times the voltage gain, let us see what is the gain in decibel. That is 20 log 10 of 0.707. This value is equal to minus 3 decibel. That means at 1 by root 2 times the when the voltage or the gain is 1 by root 2, then the change in decibel or the gain in decibel is minus 3. That means as it get reduced, there is a reduction in gain of 3 decibel. It got reduced to 3 decibel. Now here you have a slope. The slope is nothing but 20 decibel per decade. 20 decibel per decade, that means minus 20 decibel per decade. Now what does this mean? This means that for every 10 times increase in frequency, the gain in decibel, okay, in decibel reduces by minus 20 decibel. That means if the frequency increases by 10 times, the gain reduces by minus 20. Now at this point you have the gain of 17 decibel. Now and that particular point is the where you have the frequency of 10 kilohertz as given in the question. Now the frequency is moved to 100 kilohertz. That means from 10 to 100 there is an increase of 10 times. So when it from here at this point A to point B, there is a frequency increase of 10, while there is a reduction of 20 decibel, minus 20 decibel from 17 decibel. So 17 minus 20 decibel is equal to minus 3 decibel. That means when the frequency reaches 100 kilohertz, the decibel, the gain reduces to minus 3 decibel. So for the 59th question we have the answer as option D, which is minus 3 decibel. The gain in decibel is given by 20 log AV. Now what is this AV? AV is V out by VE.
An ideal differentiator using an op-amp has a high frequency gain above its maximum frequency, varying as. Now above its maximum frequency means somewhere here is its maximum frequency comes. Okay, so when you see the frequency response curve, somewhere here it increases and it becomes constant and then comes down, right? Now actually this is the maximum allowed frequency, this is the minimum allowed frequency. Now in this area it is plus 20 decibel per decade, okay, and after this area it is minus 20 decibel per decade. Okay, all right. Now what is a decade means? Decade is a tenfold increase in frequency. For example, if your initial frequency is 10 and it becomes 100, this is called 1 decade. Now 20 decibel per decade, it means that the magnitude changes around 20 decibel whenever the frequency changes tenfold. That means the magnitude of the gain changes by 20 decibel whenever our frequency changes from 10 to 100 or tenfold. This is the meaning of 20 decibel per decade. Now here the option is option A, 20 decibel per decade. This is when it is decreasing. This is when it increases.
So to get the output 1 from the given circuit, ABC should be. Now in this question, please don't go with putting selecting each one option one by one. First of all, what you have to do is find out what is Y. So this is C, and output will be C dot C bar. Using De Morgan's theorem, we get C bar plus C bar, that is nothing but C bar. Now this is A and B, so product will be AB. Now this is again an AND gate, so this is NAND gate, this is AND gate. Again you have AND gate here, so Y will be equal to product of this C bar and AB, so AB C bar. Now if AB C bar must be equal to 1, A must be equal to 1, B must be equal to 1, and C equal to 0. Only then this will be equal to 1. So what is the option? Option B.
Question number 62. A weighted resistor network is used as a 4-bit digital to analog converter. If the current through the LSB resistor is 10 microampere, what is the maximum current through MSB? The LSB is least significant bit and the MSB is most significant bit. Okay, now this is 4-bit digital to analog converter. That means there are 4 digits, bits. The last one, this is the least significant bit, and this is the most significant bit. Okay, and the numbers are given for the power as 0, 1, 2 and 3, and the corresponding values are 1 into 2 to the power 0, that is 1, 1 into 2 to the power 1, that is 2, 1 into 2 to the power 2, which is 4, 1 into 2 to the power 3, which is 8. Now the question given is, through this least significant bit, that is 1, there is a passage of current of 10 microampere. Then what will be the current through 8? That is the most significant bit. So you can write for 1 is to 10 microampere. Then what is 8 is to, now 1 by 8 is equal to 10 divided by x. This is what we have to find out, that is x. X is equal to 80 microampere. That means the current passing through the most significant bit, that is this bit resistor, is 80 microampere, which is nothing but our option D. A mod 12 counter whose output is DCBA is to be made using a ripple counter. The decoding gate for this
will have the input as which of the following options? Now from the question, it is mode 12 counter, and after the 12th cycle or after the 12 inputs, you get the output as DCBA, which is nothing but 1 1 1 1. Okay, because nothing is being negated. Now the 12th output in general is 1100. How do you get that 12th output? 12 in binary number is 1100. This is 8, this is 4, this is 2, this is 1. Okay, so 8 and 4 are there, and 2 and 1 is not there, so it will add up to 12. So this is 12th count is 1100, which means your 1100 should be the output as DCBA, which should be equal to 1111. In that case, this 0 should go to 1 and this particular 0 should go to 1. That means the last two terms, that means we have 1100, it should be written as 1111, which means this should be negated. It should be given a bar, and if you give bar to DCBA, according to this input we will get D, C, B bar. Why B bar? Because it is 0 bar, and again A bar. So this is the last output in the mode 12 counter, okay, which will be the input. So option is option C. Most metals used for temperature measurement in the form of resistance thermometer. Now this is a kind of thermometer which is used for measuring the temperature with the help of resistance in a particular metal. The variation of the resistance in the metal is used for temperature measurement. Now this electrical resistance, these metals such as platinum, nickel or copper, these are the metals that are used for resistance thermometer. Which are the metals used? Platinum, nickel or copper. And the peculiarity of this material or these metals are they linearly depend on temperature. Now according to the question, the option is positive temperature coefficient of resistance. This resistance as a function of temperature is given by RT is equal to R naught into 1 plus alpha T plus beta T square plus gamma T cube, etc. Now this linearly depend on temperature. Now R naught is resistance at 0 degrees Celsius and RT is the resistance at T. Question number 65. Which of the following is not part of lock-in amplifier? Now what is lock-in amplifier is, these are used to detect and measure very small AC voltages. So detection of signal is required. So there is a phase sensitive detector. This is a technique to single out the component of signal at a specific frequency and phase. Okay, so there is a phase sensitive detector, and it is to detect very small AC signal. So there must be a requirement of amplifiers as well as integrators. So small signal amplifier is there, integrator is there. Only thing which is not present in the lock-in amplifier is differentiator is not present in the lock-in amplifier. So your correct option is option C. Question number 66. Heterojunction devices are made up of GaAs, that is gallium arsenic, as well as aluminum gallium arsenic, because they have now the about the band gap, they have unequal band gaps. That means they have different band gap, and their structures are given here. The structures are almost similar, so they have different band gaps but similar crystal structure. Okay, so the option is option A. This both heterojunction devices made up of gallium arsenic and aluminum gallium arsenic has got different band gap but similar crystal structure. Question number 67. The output of driver is 75 ohm. The maximum power is transferred when? Now there is a law of the network, that is electronics law. That means if you have a network here and this network is feeding some voltage to the load RL, and here you have the resistance R. That means the network has the total resistance equal to R and the load as RL. Then the maximum power will be transferred when R is equal to RL. Okay, now this is the law. Now according to the option, when it is connected to a load of 75 ohm, okay, that is well and good, by using 75 ohm cable, that is not relevant. Okay, so that is one part. That means the driver has 75 ohm and the load is 75. Okay, now in the second part, it is connected to load of 75 ohm, so well and good, by single wires. So let us look into the third option. It is connected to a load of 75 by 50 ohm cable. This is not fair because it will have its own resistance. Now it is connected to a load of 50 ohm, so this is absolutely not correct. So the options which can be possible are 1, 2, and 3 is not possible, and 4 is as well not possible. So options 1 and 2 are correct. So the option according to the codes, the option D is the correct answer. That is 1 and 2 are correct and 3 and 4 are wrong.
The ground state of cesium atom. So ground state means they are asking the spectral term. Now the atomic number is 55. That means number of protons and number of electrons equal to 55. Ground state. Now this is the electronic configuration of cesium atom, and the last electron is in s orbit. So you have in s orbit one electron. Corresponding to this s orbit, we can write the spin, that is equal to half. L value of s momentum is 0, J is equal to L plus half to L plus half minus half, that's equal to half. Then you can write the spectral term L J 2s plus 1. So here you have to write the J value. So L is nothing but 0, which means yes. J value is equal to half. S 2s plus 1 is nothing but 2 into half plus 1, that is nothing but 2. So 2s half is the ground state term. So your option is B. To demonstrate Stark effect experimentally in one electron atoms, nothing but hydrogen atom, or you can say helium plus. Okay, then what is the value of electric field required? Now you know Stark effect is nothing but just analogous to Zeeman effect. In Zeeman effect you are using magnetic field. In Stark effect it is splitting is due to electric field. So very high electric field is required. To split the energy levels. So the value is 10 to the power 5 volt per centimeter. Value of electric field required.
Question number 70. In a normal Zeeman effect, the middle spectral line is now the Zeeman shift, that means the shift in the frequency is given by this particular term, that is EB divided by 4 pi ME into C, where B is the magnetic field, E is the charge of electron, M is the mass of the electron, and C the speed of light. Now here this shift in the spectral line is given by nu naught is the middle spectral line, that is middle spectral line. Now this is left and this is right. Okay, now nu naught minus EB divided by 4 pi MEC, this is circular polarized. Okay, this is also circular polarized. Left and right, left circular polarized and right circular polarized, and nu naught is not polarized, this is not polarized. Okay, these both are right and left are circularly polarized, and this is also circular polarized, and the middle one is not polarized. So your option is option C. Question number 71. One of the following elements shows doublet spectral feature like alkalis. Now alkalis are group 1 and 2. Now from the options given are boron, aluminum, barium and oxygen, and their corresponding atomic numbers are given in the second column, and the single ionization will give rise to the this many number of electrons, and by comparing their groups only barium will fall in the group 1 or 2, which makes it have a doublet spectral feature similar to alkalis. So the barium is the correct option, that is singly ionized barium, the option C.
A proton having a magnetogyric ratio. Magnetogyric ratio is same as gyromagnetic ratio gamma of 3 into 10 to the power 8 radians per Tesla second is processing in a magnetic field strength of 5 Tesla. That means external magnetic field B naught is equal to 5. Its NMR frequency is nearly, or it can be also asked emitted frequency. Emitted frequency also can be asked, or NMR frequency. So NMR frequency is given by nu equal to gamma times B naught by 2 pi, where gamma is gyromagnetic ratio, B naught is external magnetic field. Just substitute the value. Nu is equal to gamma is nothing but 3 into 10 to the power 8 radians per Tesla second into B naught, magnetic field is 5 Tesla, divided by 1 by 2 pi radians. Now that is equal to Tesla gets cancelled, radians and 2 pi goes here, radians. So here what is left is 3 into 10 to the power 8 into 5 divided by 2 pi is nothing but 6.28 into 1 by second or hertz. So this is equal to 150 by 6.28 into 10 to the power 8 hertz. So what is that? You will get a value around 2.39 into 10 to the power 8 hertz. So that's equal to, nearly equal to, you can write 240 megahertz, which is nearly equal to this 250 megahertz. So this is the formula. Please remember this formula from this question. Nu is equal to gamma B naught by 2 pi. Gamma is gyromagnetic ratio, B naught is the external magnetic field.
Question number 73. In Born-Oppenheimer approximation, the following assumption is made. Now, what is this Born-Oppenheimer approximation? This Born-Oppenheimer approximation is used to describe the quantum state of the molecule. Quantum state of the molecule. Okay. Now, to describe the quantum state, we have to assume that the electronic motion and the nuclear motion has to be separated. To describe, we have to separate both the electronic motion and the nuclear motion. And to separate this, we have to consider nucleus as stationary. So the option that we have here is the option D, that means nuclei remain stationary in relation to the fast moving electrons. This is a molecule, this is atom A and the atom B. In this, we are assuming this nucleus as stationary, while this electrons, which is given in the color red, keeps moving. Question number 74. For the molecules, the state sigma 1 refers to. Now, the sigma 1 is nothing but 2j plus 1 sigma. Okay. Now, what is this j? J is the total angular momentum. Total angular momentum. Quantum number. Okay. Momentum. Quantum number. Okay. You can write total angular momentum. Now, when 2j plus 1 is equal to 1, that means here
1 is equal to 2j plus 1. So 2j plus 1 equal to 1 implies 2j is equal to 0 and j equal to 0. And what is j? J is nothing but L plus S. Now L plus S is equal to 0. This implies L equal to 0 and S equal to 0. L equal to 0 is orbital angular momentum. Orbital angular momentum is 0 and S equal to 0 means spin angular momentum equal to 0. So both orbital angular momentum and spin angular momentum are separately equal to 0. So the option is C, that is both spin and orbital angular momentum of the electrons are 0.
If the average separation between adjacent lines of rotational in IR spectrum of carbon monoxide molecule is 3.844 centimeter inverse, then what is the rotational constant? That is the question. Now the separation f of j, that means f is a function of j, it is written as b into j plus 1. Now where b is called rotational constant. Rotational constant. Now this f of j value is given as 3.844. Okay, this is equal to b into, now what should be the j value? J value, delta j, we have written it as plus or minus 1. That is the selection rule. This is called selection rule. Then j, if j equal to 1, j plus 1 equal to 2. So b into j plus 1 is equal to 1 into 1 plus 1, that is 2. So then what is b equal to? B is equal to 3.844 centimeter inverse divided by 2, that is equal to 1.922 centimeter inverse. So your option A. Now if delta j is plus 1, this is called absorption. Delta G minus 1, emission. Okay.
Question number 76. For the vibrational transition 1 from 0, if the band is referred to as fundamental, then the transition to 2 from 0, the band is called what? Now let us see. 0 to 1, this is called fundamental band, and 0 to any other level greater than 1 are called overtones, and from 1 to any other level greater than 1 are called hot transition or hot bands. Now in this figure, 0 to 1 is the fundamental band, and from all other transition from 0 to 2, this is called first overtone. 0 to 3 is called second overtone, and from 0 to 4 is called the third overtone. Now from 1 to 2, that is our third criteria, these are called hot bands. 1 to 2, 1 to 3 and 1 to 4, these are hot bands or hot transitions. So from in the question they are asking from 0 to 2. So from 0 to 2 is the first overtone. So the answer is option B, first overtone. The ratio of the spontaneous emission process probability to the stimulated emission process probability. These are Einstein's coefficients. Einstein coefficients, that is, the spontaneous emission process probability is A and the stimulated emission process probability is B, and the ratio of A by B is equal to 8 pi h nu cube divided by c cube. Or if you want to write in terms of the angular frequency, you would get h omega cube divided by pi square c cube. So in this you can understand that the ratio A by B is proportional to the transition probability cube. So from the option, it is the option D, that is the ratio of A by B is proportional to the cube of the transition frequency.
For an electron configuration in which there is one s electron and one d electron, the resultant spectral terms are. Now, according to the question, you have one electron in s orbit and another electron in d orbit. So here you have another electron. So this is s and this is d. Now the total angular momentum L, for s you have 0, for d you have 2. S spin is equal to half. Here also you have half because one electron is present. Total L equal to 0 plus 2, that is 2. Total S is equal to half plus half, that is equal to 1. Now J value is from L minus S to L plus S, which is equal to L minus S is nothing but 1 to L plus S is 3. So J values are 1, 2 and 3. Now how will you write your spectral term? Spectral term is represented by L J 2s plus 1. This 2s plus 1 represent SS coupling, L represent LL coupling, and this J represent LS coupling. Now L value is equal to, total L value equal to 2, S value equal to 1. So L value equal to 2 represent which state? 2 represent D state, D. Then J values are 1, 2 and 3. 2s plus 1, S is equal to 1, 2s plus 1 equal to 3. So spectral terms are either D13, D23 and D33. These are the spectral terms. In a BCC lattice with lattice constant A, the body centered position from the origin is at a distance of, body centered position of atom or molecule, anything. Okay. Now this is the BCC structure. You have lattice constant A, this is also A, this length is also A. So this will be root 2 times A using Pythagoras theorem. So considering another right angle triangle here, this will be right angled. So here also this is A, so root 2A, root A, so hypotenuse will be root 3A. Now what is the question? Question is from the origin, let us take this as the origin. From the origin, the distance of this atom, so there will be an atom at the center, so from to the center, what is the distance? This is what is asked. Okay, so what is that? This will be half of that, so root 3 by 2 times A is your answer. So root 3 by 2 A, option C. In a cubic crystal, the interplanar spacing of HKL plane is represented by DHKL. Which of the following is true? Now, before going into the option, let us write down the formula. DHKL, the distance is given by A divided by under root H square plus K square plus L square. Now, let us write down one by one. A divided by root 3 and A divided by root 1. It is said it is greater. So this one is greater. So this is false. So A divided by root 2 greater than A divided by root 3. So this is true. So you need not check the remaining options. Option B is correct. But still let us check. A divided by root 3 less than A divided by root 5. A divided by root 4 greater than A divided by root 3. So here this is greater, so this is also false. Here this is greater, so this is also false. So option B.
Madelung energy is calculated in. Now what is Madelung energy? Madelung energy is nothing but the electrostatic energy. This is the electrostatic energy, that is the Madelung energy. We are describing it as the electrostatic energy between the ionic ions, between the ions in an ionic crystal. So this is about ionic crystal. So it's cohesive energy, that means the attractive energy of the ionic crystal is due to electrostatic energy, that is the Madelung energy. Now Madelung constant allows for the calculation of the electrostatic potential, that is Vi, of all ions in the lattice felt by the ion at the position Ri. Now what does this mean? Now assume that this is the crystal and I am going to calculate the Madelung constant or Madelung energy for the ith particle, that is this is the ith particle. Now all these are J. Okay, all these ions are J. I am assuming this is of a positive and all J's are of negative. Now what is this Madelung constant or Madelung energy? It is the potential of this particular ion, that is the positive ion at the center, due to all these ions or charged particle in electrostatic. When we can say this is sum of all the electrostatic energy or the potential due to the neighboring ions. So in this formula Vi is equal to E by 4 pi epsilon naught sum over Zj divided by Rij, where J not equal to I. And what is Rij? Rij is the distance between, this is Rij for the first term or the first particle interaction. This is second Rij. Similarly all. Okay, so Madelung energy is for calculating the energy for ionic crystals. The total potential energy of the pair of inert gas atoms at separation R is given by V of R is equal to minus A by R power 6 plus B by R power 12, where A and B are positive constants. The question asked is, what is the repulsive force between the two atoms? Now what we know is the force F is equal to minus dou V by dou R. So we have the potential, that is, let me write dou by dou r of what is V. V is minus A by r power 6 plus B divided by r power 12. Now let's differentiate this. That's equal to minus of the first derivative of minus A by r power 6 is minus 6 with the minus sign into A divided by r power 7 minus 12b divided by r power 13. Okay, now just give this negative sign inside. This becomes minus 6a by r power 7 plus 12b divided by r power 13. Now for a force, if it is positive, we say that it is repulsive force. If it is positive, we say that it is repulsive force, and if it is negative, we say that it is attractive force. Okay, now in this force, the equation that we have got, the negative sign, this is the attractive force and this is the repulsive force. Now the question they have asked is find the repulsive force. So the repulsive force F R is equal to, is this R represent the repulsive is equal to 12b divided by r power 13. If the question was asked what is the F attractive, the answer would have been the minus 6a divided by r power 7. But according to this question, the question asked is repulsive force, so your option is option B.
In a crystalline solid with n number of unit cells, the number of allowed independent phonon modes of a branch is. Now crystal vibration you can classify as acoustic and optical vibrations. These are frequencies, acoustic frequency and optical frequency. It represent lower, this is lower frequency and this is higher frequency. Okay, now in one dimension, if there are n atoms, then total number of phonon vibration will be equal to n, where again you can classify the n vibrations. Few of them will be optical and others will be acoustic. There is only one acoustic and n minus 1 optical frequencies. This is for one dimension. Now for two dimension, so this is number of vibrations, phonon modes, you can write phonon modes n. For 2D there will be 2n phonon modes or phonon vibration. Out of that, 2 will be acoustic and 2n minus 2 will be optical. Similarly for 3 dimension, if there are n particles or n atoms, there will be 3n modes of vibration, out of which 3 will be acoustic, while 3n minus 3 will be, what is left in 3n, that will be optical vibration. So according to this question, this it is not sure in which dimension is unknown. Dimension is a question mark. If it is one dimension, there will be n number of phonon modes. If it is two dimension, there will be 2n number of phonon modes. Okay, this is the question. Number of phonon modes is the question. So please remember, in one dimension n phonon nodes, one is acoustic, n minus 1 is optical. In two dimension there will be 2n. This n atoms remain constant. So for two dimension there are 2n modes of vibration, while 2 is for acoustic, 2n minus 2 is for optical. Similarly for three dimension, 3n modes of vibrations will be there, phonon vibrations, in which three modes of vibration will be acoustic and 3n minus 3 will be optical vibrations. Heat capacity Cv of a metal is measured as a function of temperature in low temperature region. Assume that measured Cv is due to both electrons and lattice. Then plot of Cv versus T. Sorry, Cv by T versus T. So you have Cv is proportional to T cube. For metals we have, for metals, alpha T cube plus gamma T. This is what it is. Now what the question is, you have to find out Cv by T. Cv by T will be equal to alpha T square plus gamma. Now you have to plot a graph with the Cv by T on y-axis and T on x-axis. So Cv by T is proportional to alpha T square, so it is proportional to T squared. So T square and T, so you will get a curve in this way. But according to the option, linear in T squared means you have Cv by T on y-axis and x-axis you have T square. Then you get a linear graph. Cv by T here is proportional to T square. So T square and T square on x-axis and y-axis, if you have T square, you get a straight line. So this is linear in T squared. If this was the question, Cv by T and T along x-axis and Cv by T along y-axis, this is the graph. Okay, so you can keep it linear in T square. In metals A and B, electron densities are Na and Nb respectively. Their respective Fermi wave vectors are KFA and KFB. Then that means if KFA equal to 2 times KFB, then which of the following is true? Now since this is metal, that means metals, you can C of electrons are there, C of electrons, so we can consider it as a gas of electron or electron gas. All right, electron gas, which is in 3 dimension. For 3 dimension, your wave vector or Fermi wave vector is proportional to n3 whole to the power 1 by 3, where 3 represent the dimension. If it was 2D, kf2 is proportional to n2 whole to the power 1 by 2. If it was 1 dimension, wave vector is proportional to n1 whole to the power 1. Okay, since it is 3D, your Fermi wave vector is proportional to n power 1 by 3, where n is electron density. Now let us take the question. KFA by KFB is equal to 2, which is proportional to what? N to the power 1 by 3. So we can write Na by Nb whole to the power 1 by 3. Now just take these two equations, that is 2 equal to Na by Nb whole to the power 1 by 3. So which means Na by Nb is equal to 2 to the power 3, which means Na equal to 8 times Nb. So 8 times Nb, your answer is option D. Now this is true only if we are talking about 3D, and since it is metal, it belongs to 3D. Okay. So please remember this formula from this question. Kf proportional to Nd whole to the power 1 by D, where D is the dimension. In which dimension you are talking about? Dimension of, okay. A metal wire of radius r and electron density n is carrying a current I. Then the drift velocity Vd of the electron in the wire. Now drift velocity Vd is given by I divided by NEA, where A is the cross sectional area. So cross sectional area means pi r squared. So I divided by Ne pi r squared. So your option is B. Now what is Vd? Vd is the average velocity. Average velocity with which electrons move when electric field E is applied. Okay. Now this question you can also use dimensional analysis. Dimensional analysis to get into the correct option. Now how? You check the first of it. Now what you need Vd. Vd means drift velocity, which is a unit of velocity. So meter per second. This is what you need. Now each option should give you meter per second, otherwise that is not wrong. That is wrong. So let us take the first option, that is I. I means charge per second. Charge per second. Pi as it is you can write, no need. So r square is nothing but meter squared divided by n is number per meter cube into charge cube. Now this is not equal to meter per second. So charge and charge get cancelled, but this meter cube will go to the numerator and will become meter power 5. Okay, so you cross out your option A. Now check the option C. You get Q by second. N is, as I told, number per meter cube. E is nothing but the charge again, and pi you can leave, r square is meter square. Still this is not equal to meter per second. Now check out the fourth option. So you can cancel out option C. Now option D you can check. I is Q by second into 1 by r is nothing but 1 by meter. N is nothing but number per meter cube. Okay. E is nothing but the charge. Now let us see what is it is. Q and Q gets cancelled. Second remain m and m cube, m square remains. So m square divided by second. So this is also not equal to meter per second. So you can cancel out option D. So your option B is correct. If you want, you can check out that one also. I is nothing but Q by second. 1 by r square is 1 by meter squared. N is nothing but number per meter cube into 1 by charge q. Q get cancelled, meter square and meter square get cancelled, meter remains, which is equal to meter per second. So your option B. So this is how you can get into the answer even without knowing the actual formula. So please try to use dimensional formula whenever you are not able to get anything out of the question. Application of Hall effect R. So before going into this question, application of Hall effect, let us understand what is Hall effect. Now this is your Z axis, this is your X axis, and this is your Y axis. Now here you have a metal or any object, you can say. Now you have applied a potential such that the electrons are moving in this direction. Electrons are moving in this direction and your current will be in opposite direction. And a magnetic field is applied along this Z axis. Magnetic field is along this Z axis. Now according to your left hand rule, left hand thumb rule, these electrons will be deflected downwards due to the force F is equal to Q into V cross B. And since V and B are in different directions, V is along X axis and B is along Z axis, your force is along Y axis, right? Or the you have an electron moving in the Y axis, that means towards the Y axis. Now we know that the electrons will be placed here, right? All electrons are in the bottom part. Now due to which your positive charges will be, if it is a metal, positive charges due to induction, positive charges will be on the upper surface. So there is a potential developed. This is positively charged plate, this is negatively charged plate. There is an electric field developed. Electric field in which direction? Electric field in the negative Y direction. So EY is given by minus JX BZ by NE. This is the value of the electric field developed. This development of electric field is proportional to Jx, where Jx is the current density. And Bz is the applied field, magnetic field B. N is the charge density, and E is the charge of the electron, or you can write Q if you are not sure about what charge. Now if this can be found out, now you see which all the quantities we can find. You can find out the magnetic field, you can find the type of the charge, you can also find density of the charge. This is type of the charge and this is density of the charge. So it can be used to find out the charge carriers, type of the charge carriers, density of the charge, and unknown magnetic field. So all the three given options are correct. So what is the code? Code is A, 1, 2 and 3 are true. Which of the following is not true? A superconductor is characterized by. Now superconductor, option A is persistent current. Now the idea of superconductor is arising only because of its conductivity. Its superpower to conductivity of electrons. So the current, conductivity of electron means existence of current. So option A is true. Now perfect diamagnetism. The magnetic field inside the superconductor is equal to 0. This is always true, but depends on temperature. Existence of energy gap. So this is B also true. Now existence of energy gap. This energy gap does not mean the gap between the energy levels. It means to break Cooper pair. Cooper pair is responsible for conductivity, scattering of phonons. Scattering of phonons. That energy required is nothing but the energy gap. So this is also true with respect to conductor, superconductor. Now heat capacity, there is no relation, no specific relation we have to say. At some temperature it behaves linearly, but not always. No specific relation with the temperature. For CV, specific heat capacity. Okay. So your option is D, which is not true. Given below are two lists of statements. Match the items in list 1 with those in list 2. First one is point defect. Point defect, it increases with increase in temperature. Just remember the case of your semiconductors. Okay. Now superfluidity. Superfluidity is a phenomena, and this is an effect, fountain effect. This effect is due to superfluidity. What do you mean by superfluidity? Or superfluidity means there is no viscosity. That means the fluid will flow indefinitely. If you stir this superfluid liquid, it will be keep rotating indefinitely. This is what is meant by superfluidity. Now liquid crystals. Liquid crystals have orientational order. Insulators, high energy gap. Now Meissner effect is related to superconductivity. So superconductors. So you can check the option 1 belongs to 3, 1 all the 3, okay, and 2 belongs to 2, 1, 3, 2, 2. So option D. Now let us write down this equation here. Muon plus electron plus, that is positron, plus electron neutrino. Now let us see what about the charge. Charge here there is 1, that is positive 1 plus. This is again 1 plus. This again electron neutrino, the charge is 0. So charge is conserved. Plus 1 on the right side, plus 1 on the left side. Now about lepton number of electron. On the right hand side there is no electron particle, so 0. Electron plus, that is E plus, what is the lepton number? Minus 1. Electron neutrino plus 1. So this is conserved. Lepton number is conserved for electron. Now for muon. Muon plus. So this is electron number minus 1 changing to on right side you don't have any muon, so 0, 0. So this is not conserved. Lepton number for muon is not conserved. Now isospin. All are not an isospin particle. Their isospin is 0, so it is conserved. Now what we left with baryon. Now since all are leptons particle, the baryon number on right side and on the left side is 0. So this is also conserved. So what is not conserved? Lepton number for mu. So lepton number is not conserved. Half-life of a radioactive sample is 20 days. This means that now if there are 100 radioactive atoms, so 100 atoms, these are radioactive. Now after 20 days it will become 50. This 100 atoms will become 50. This is what is meant by half-life. After 20 days it will become half. Again after 20 days it again will become half of what is left, so that will become 25. This goes on. So radioactive is omnipresent, that means it is all over, and it will not get decayed, it will not become zero, because if you keep dividing it, it won't become zero, you won't get a value 0. It will be very near to 0, but you won't get a value near to 0. So you got an idea what is about it. Now how many half-lives are there? N is equal to number of half-life. Okay, now after n number of half-life, how much of the particle or how much of the radioactive element is left is given by, if n is the initial number, or you can write n naught, divided by 2 to the power n, where n is number of half-life. So here they are telling substance completely disintegrates after 40 days. No complete disintegration takes place. Substance completely disintegrates after 80 days. Here also completely disintegrates doesn't happen. 1/8 part of the substance disintegrate. 1/8 part of substance disintegrate means what? Let us see. In 60 days. 60 days means if you divide it by the half-life, you will get 3 half-lives. So n is equal to 3. Just substitute here n naught divided by 2 to the power 3. So that is 1/8 of n naught. 1/8 of n naught, that it is left. What is left? After n half-life, what is left is n naught by 8. It is not 1/8 of substance disintegrates. What is that? 7/8 will get disintegrated and 1/8 will remain. 7/8 of the initial number will get disintegrated and 1/8 will remain. So option D, 7/8 part of the substance disintegrates in 60 days. That means 60 days means 3 half-life. The decay of proton to positron and gamma. Now since there is a presence of gamma, it can be a electromagnetic interaction. This is just our intuition. Now let us understand. For any interaction to happen, charge, lepton number and baryon number must be conserved. These are called primary quantum number. Primary quantum number. Okay. So if any one is not conserved, either Q, L or B is not conserved, then interaction is forbidden. That is not allowed. Interaction is forbidden. Not allowed. It's not possible. So for any basic interaction, Q, L and B numbers must be conserved. Alright. Now let us take the interaction. Proton changing into positron plus gamma. Let us see about charge. Proton charge is +1. Electron, that is positron charge, is again +1. Gamma does not have charge. So Q is conserved. Charge is conserved. Now you have a lepton here. Let us take lepton. Lepton number for electron. Proton is not a lepton number, so 0. Here positron have a lepton number -1. Gamma does not have a lepton number, so this is not conserved. Similarly, you take for baryon number. Proton is a baryon, so you have +1. Positron is not a baryon, 0. Again, gamma does not have a baryon number, so this is also not conserved. So L and B not conserved, only charge is conserved, so this is not allowed. The interaction is not allowed. So your answer is B. The function of a moderator in nuclear reactor. Now what happens here? Once the first fission occurs, there will be about 2 to 3 neutrons. These neutrons will be of high energy, but these high energy neutrons are not efficient, so we have to bring it to the thermal energy. So they are called thermal neutrons, to reduce the energy so that collision occurs with the fissile material. Collision occurs with the fissile material effectively. Okay, fissile material, you can talk about uranium-235. Okay, so this has to be done. So this process is done using moderator. Now your option B is the correct one. Now look at this option A, to absorb unwanted neutrons. This unwanted neutrons is being absorbed by graphite, carbon. Okay, carbon rod. We are using carbon rod for absorbing this unwanted neutrons. Okay, so here the option B is the correct answer. Quark contents of delta plus and proton. Now proton you already know, U and D. Up has 1/3 plus charge, sorry 2/3 plus, again 2/3 plus. Down quark is having -1/3 charge, so together you will get +1 as the charge. So proton is plus positive charge, so U and D. Now what here given is, it is spin 3/2 baryon quark structure. Okay, so spin 3/2 baryon quark structure you have. This is represented in decuplet. Okay, now it starts from delta double plus and ends in delta minus in the first row. And here you have sigma plus, sigma naught, sigma minus, cascade naught, cascade minus, and omega minus. And the corresponding quark structure is given here towards the left. It starts from triple U. That means delta plus plus or double plus is having U as the quark structure. Delta plus is having UUD. Delta naught UDD, and it goes. So corresponding to each particle. So this is all particle arranged in this decuplet. 10 particles are there. Spin 3/2. How many particles? 10 particles arranged in decuplet. Now spin 1/2 baryon, it is arranged in octet. Okay, all right. Now you can see omega minus is triple S. All are strange particles. Okay, and your question needs delta plus. Delta plus is having UU and D. So both proton and delta plus is having same quark structure. So your option C is the answer. S indicate strange particle, D is down, and U is up quark. So this is up quark, this is down quark, and this is strange quark. Okay, that's it. Now the middle one, that is in the center, you see the combination of all the three, U, D and S, that is having zero charge. Number of S indicates the strangeness of that particle. For example, I want to find out the strangeness of delta plus, sorry, sigma plus hyperon. I want to find out its strangeness. Now immediately go to its position in the quark structure. So SUU, how many S are there? 1. So strangeness is equal to -1. When you come down to the next level, for cascade naught and cascade minus, there are 2 S, which means strangeness is equal to -2. Okay, for this omega minus, how many strange particles are there? 3. So this is omega minus is having 3 strange particles. So S is equal to minus.
The ground state of a deuteron is an admixture of the following state. Now, deuteron is the a group of proton and neutron. Now this proton and neutron both are spin half particles, so the spin value is equal to 1, and for neutron value also spin value equal to spin is half, and for proton and neutron, so the net spin is equal to 1. Now according to the wave function of the deuteron, we have psi is equal to the AS, that is the coefficient of the AS state, the wave function at L equal to 0, plus AD at the wave function psi at L is equal to 2. Now at L equal to 0 and L equal to 2, these are the two states. Now this is L equal to 0 represent the S state, while L equal to 2 represent the D state. Now since the spin is equal to 1, it gives 2s plus 1, so let us write down 2s plus 1 is equal to 2 into 1 plus 1, so that's equal to 3. Now for both S and D, we have the triplet state, Now going back to the option, we have the only option that gives the triplet state are this option C, which gives the triplet state of S and triplet state of D. So the option is option D. So how you write the state is L, J and 2s plus 1. So the first one is L equal to 0, so you can write S, J value is 1, and this is a triplet. Now for the second one, D, you have the triplet state 3 and corresponding values of J are 1, 2 and 3, either of this. So according to the options, you have 3s1 and 3d1 as the admixture of the state. Now, how many percentage? What is the percentage of yes? Yes is around 96 percentage, and D state, that means the particle or the neutrons in ground state has a probability, that means it is in ground state at yes, that is 96 percentage, and only 4 percentage it is in the D state. This also you can remember as part of this question.
The energy dependence of the cross section of a reaction between two particles close to the resonance energy E is described by. Now let us see the options one by one. First is the Bethe-Bloch formula. Bethe-Bloch formula is describes the mean energy loss per distance traveled by charged particle in any matter. Now this charged particle can be either proton, alpha particle, or any ions. Now it is also called the stopping power of the material for a certain charged particle. Now the option 2, which is the Breit-Wegner formula. Breit-Wegner formula describes the resonance in neutron cross section in terms of energy. On the left hand side, what you are seeing is the Breit-Wegner formula for the cross section. This K divided by E square minus M square whole square plus M square gamma square, where E is the center of mass energy that produces the resonance, M is the mass of the resonance, gamma is the resonance width or decay width related to its mean lifetime according to tau equal to 1 by gamma. Now the option C is Gamow-Teller formula. This is a selection rule, or you can also say it as a Gamow-Teller rule used for beta decay for the transition involving no parity change. There is no parity change for the transition. The option D is Weizsäcker formula. Weizsäcker formula is an empirical formula used for finding out the binding energy of the nuclei for in a liquid drop model. It's an empirical formula for liquid drop model. Now, according to what we have discussed about all four options, the option that satisfies the question is option B.
Mass defect of an atom divided by its mass number. Now what is this mass defect? Mass defect is nothing but the isotopic mass minus the mass number divided by the mass number. That is nothing but our packing fraction. Now this packing fraction can have 0, -1 or +1. These are the possibilities. 0 means this is monoisotopic. There is no other element, there is isotope present, so that is indicated by 0. Now -1 means there is reduction in mass, so binding energy is present. They are stable. Okay, now +1 indicate they undergo fission and fusion. They are unstable. For fission we have uranium-235. For fusion we have H11. Alright, so here our answer to this question is packing fraction, mass defect divided by the mass number, packing fraction. For deuteron, packing fraction is nothing but binding energy. This is what the question is. Now what is deuteron? Deuteron is nothing but hydrogen plus hydrogen plus 1 neutron. You add neutron to the hydrogen atom, you get deuteron. Okay, so that's it. Now you want the neutron mass. Neutron mass is given this much, 2.014102 mu. Now you want mass defect, delta m. Delta m is equal to hydrogen atom mass of the hydrogen atom plus mass of the neutron minus the mass of deuteron. Now the values are given, you can just add it up. 1.007825 plus 1.008665 minus the mass of neutron. Neutron is this, sorry, mass of the deuteron. Deuteron is 2.014102. Now this sum is equal to 2.01649 minus 2.01410. What you get is 0.002388. Now this is delta m. Now what you want energy? Delta m into 931.5 million electron volt. So that's equal to, what you're getting is 2.224422 million electron volt. Now this is for two nucleons, right? Two nucleons are there. This hydrogen atom plus one neutron. Hydrogen atom is having a proton and one neutron. So these two are two nucleons. So if you divide by 2, what you're getting is 1.1122 million electron volt per nucleon. So your answer is option C. Radius of a nuclei whose mass number is 216. Now how to find radius? Radius is equal to R0 into a to the power 1 by 3, where a is the mass number. Now we want to find out R. R is equal to, R0 value is given as 1.2 into 10 to the power minus 15 meter. A value is given as 216, a power 1 by 3. So that's equal to 1.2 into 10 to the power minus 15 meter. This cube root of 216 is nothing but 6. That's equal to 7.2 into 10 to the power minus 15 meter. So your answer is option A. So please remember this value from this question. Equation R is equal to R0 at power 1 by 3. And we are into the 100th question. The question is, for the magnetic multipole transition, the parity is. Now let us understand what is this parity for. This parity we are discussing is about gamma transition. Gamma transition, we need parity. And what is parity? Pi is equal to minus 1 whole to the power L. This is the total angular momentum, L. Okay. L value for the particular state. Now for the parity pi, this is given by initial parity times the final parity. Now the parity can be either odd or even. So this is an even parity, and here we have the odd parity. Okay. Now for even parity, the electric multipole transition E will be even. Okay, and because electric multipole transition will remain same, so E even as, let me write E equal to even, and the magnetic multipole transition M is odd.
because E will remain same and M will change, that is magnetic multipole transition will change. Now when we coming to the odd parity, here also the electric multipole transition will remain same, so E parity is odd while the M, the magnetic multipole transition is even. Okay, now look at the question now. For the magnetic multipole transition, so this is what we need, M and M. So this M equal to odd when parity is even, right? Odd for even parity, and here you have M equal to even for odd parity, right? So odd for even L is parity, that means pi is equal to -1 whole to the power L. Now if L equal to odd, we have pi equal to odd. If L equal to even, pi, the parity will be equal to even. Okay, so odd for even pi and even for odd pi. Fine, so the option is option A.